So, imagine you're 15 and you get bored of playing video games. Instead, to pass the time, you decide to give some attention to an old hobby of yours, tracking down lost Mayan cities. You've heard that some ancient civilizations are said to have built entire cities based on constellations, so you decide to check out whether that was true for the Mayans. You find a book containing all the constellations the Mayan civilization believed to exist. You open good old Google Maps and map every ancient Mayan city discovered to date. You start seeing that this information actually matches. And truly, the biggest ancient Mayan cities correspond to the brightest and biggest stars of the Mayan constellations. Okay, this is getting interesting. You manage to map out over 100 ancient cities when you suddenly notice something strange. There's an area in the Yucatan Peninsula in Mexico where archaeologists have unearthed 2 Mayan cities. But on the constellation map, there are 3 stars. Could this mean there is a long-lost city waiting to be discovered nearby? You might think this sounds too daydreaming, but the story is actually true. The previous account happened to a Canadian teenager named William Gaddery. The boy is known as a science genius and had even won an award for the constellation theory we presented just now. When he noticed that a 3rd city was missing from the 23rd constellation he was examining, he began to scour the internet for satellite pictures that could help him solve this mystery. He looked into images from NASA, JAXA, a Japan-based satellite company, and Google Earth. These images were still insufficient to answer his questions, so he reached out to a friend inside the Canadian Space Agency. His friend provided him with state-of-the-art satellite imagery that gave him the answer he was looking for. According to the images, there is a large square area right on the border of Mexico and Belize, which looks like the remains of a city. William took the images to a remote sensing expert known as Dr. Armand Larocque from the University of New Brunswick. They studied the images thoroughly and concluded that the area could be housing 30 buildings and even a large pyramid. The scientific and archaeological community went crazy with the 15-year-old's discovery. Could this really be true? Some background. Lost Mayan cities began to be unearthed in the mid-20th century. Since then, ruins from cities such as Tikal, Palenque, and Uxmal have been rediscovered. The Mayans were one of the biggest pre-Columbian civilizations living in the Americas. They began to settle in the area as early as 1500 BCE. Experts believe that, at its height, the Mayan civilization consisted of over 40 cities, with a population of millions of people. That's a crowd. And their cities were pretty interesting. Their civilization spanned over Mexico's Yucatan Peninsula, Guatemala, and Belize. They survived mainly on agriculture, so they developed a complex irrigation system in most of their cities. They built a series of ceremonial buildings, pyramids, plazas, and even courts for ball games. The Mayans were keen pyramid builders, but they also developed an advanced astronomical system. With whatever ancient technology they had, they were able to predict the exact location of planets, such as Venus and Mars, and they were able to predict the exact dates of eclipses. That's why the methodology William used to discover this long-lost Mayan city was unusual, but not completely surreal. The Mayans were keen astronomers, so it wouldn't be too strange that they built their major architectural feats in relation to the sky, would it? And they wouldn't be the first ones to be doing so. There is a famous fringe of Egyptology dedicated to studying how the Giza pyramids were built in perfect alignment with the Orion constellation, meaning that each pyramid was purposely built to align with one of the major stars of Orion's belt. According to William, he first had the idea to look at the Mayan constellations because he couldn't understand why the Mayans built their cities where they built them. Most major cities, such as Chichen Itza and Uxmal, aren't near any rivers or significant bodies of water. Instead, they're built on marginal lands and on top of mountains, which confused the 15-year-old. His next thought was that it might have something to do with astronomy. William named the new city he discovered Mouth of Fire, which is also my nickname, and he even won a merit award for his hard work. However, his theory was very much contested inside the archaeological community. and many Mayan experts work to debunk Williams' findings. Some archaeologists say that constellation theories are too unscientific. Anthony Aveni, a renowned anthropologist and astronomer, referred to Williams' methodology as an act of creative imagination. He explained that there is no way to be sure what the Mayan constellations really were. It's all just hypothetical. Another debunking of Williams' findings came from Mayanist David Stewart, who said that the object identified on the satellite imagery is nothing but an old cornfield. His claim was supported by an expedition that took place near the area in 2021, when the archaeologists present reported there was nothing at all in this area. Still, a 15-year-old boy almost found a long-lost Mayan city, which is pretty exciting if you ask me. Similar techniques as those used by William are actually being used to unearth lost civilizations all over the world. According to space archaeologist Sarah Parquet, satellite imagery has been a key player in discovering ancient cities in Egypt and other places. Sarah herself spends most of her days scouring images for any sign of where there could have been cities long ago. What happens, she says, is that any time you have something buried, it's going to be covered either by vegetation, soil or sand, or some other modern construction on top of it. In order to assess whether there is something hidden under large canopies of vegetation or not, she uses infrared technology, for instance. A major recent discovery in Brazil was done in a similar way. Satellite imagery detected a network of trenches dating back to 200 to 1200 CE. These suggest settlements that could have supported around 60,000 people. But in this case, the satellite imagery did indeed correspond to what was on the ground. Researchers from the University of Florida found several mounds that were accompanied by ditches and geoglyphs. Archaeologists also found remnants of carefully designed walls, centered around plazas, much like the type of construction done by the ancient Mayans. Advances in satellite tech have also shed new light on long-discovered ancient Mayan cities, such as Tikal. Located in the heart of the Guatemalan jungle, Tikal is believed to have been the capital of the ancient Mayan Empire. At its height, it was comparable in importance to cities such as London or New York in today's world. It was composed of a series of complex monuments, many of them believed to have been the resting places of kings and chiefs. Tikal is already known to have been big, but recent discoveries show it could have been even 3 times larger than what scientists originally believed. The main discovery revolves around a fortification on the outskirts of the city, indicating how far the original city stretched. And new discoveries still take place. In 2017, researchers also unearthed new clues regarding the potential causes of the decline of the Mayan civilization. Using data from a Sidon seawall located 62 miles southwest of Tikal, scientists analyzed radiocarbon data from ceramics and archaeological excavations to extract new information about the sudden demise of this great civilization. The information shows that, instead of a sudden collapse, the Mayans most likely collapsed in waves of social instability and political crises. These events are believed to have deteriorated Mayan city centers and began causing the dispersion of the Mayan population. Wow, it seems like it's a prime time to uncover ancient ruins. What do you say? Will you give it a try as well?
Ever since Plato wrote about the allegory of Atlantis, humanity has been fascinated with the possibility of the discovery of a thriving underwater civilization. Fancy joining me on a trip to a few historic underwater sites? Let's see what we can find out about ancient civilizations. The first one on our list is what is being called the underwater Stonehenge. Scientists have recently discovered a mysterious pile of cairns that stretch for miles under the shimmering waters of Lake Constance at the borders of Switzerland, Germany, and Austria. Archaeologists began to explore the site back in 2015, and they haven't been able to understand yet what it was actually used for. What they do know is that there is a 12-mile line of 170 human-made stone cairns under Lake Constance. Scientists say this was most likely the result of a combined work of several villages. The cairn site was probably used for some collective purpose. The formations are huge. Some of them are several dozen feet wide. The most amazing discovery so far is that the site dates back to around 5,500 years ago. Now, what were we humans doing back then? We were living in the prime years of the so-called Stone Age. We were beginning to make artifacts from stone and use them to hunt and eat. Can you imagine what a knife and fork might have looked like back in those days? It's no coincidence that scientists call this site the underwater Stonehenge, though. Both sites are believed to have been built around the same period of time. You see, Stonehenge dates back to around 3,100 BCE. Both sites carry the distinct characteristic of stone monuments built in a circle. Not to mention the fact that scientists also haven't figured out why on Earth our early ancestors would feel the need to build a monument such as Stonehenge. Well, the mystery of Lake Constance hasn't been solved yet. Who were the Neolithic people from this area? And for what purpose did they go through such an amount of work and effort to build this huge stone site? Next, we're taking you on a tour of the Ryukyu Islands just off the coast of Japan. You're diving deep down to an archaeological site. But I should warn you, the waters of the Pacific Ocean are far from smooth. It doesn't take long before you see a huge structure, thanks to the sunlight shining down on the seabed. At first, it looks like Machu Picchu's ruins located across the globe in Peru. As you approach the site, you slowly figure out its forms. A pyramid-shaped structure, arches, staircases. It's something that could have easily been a palace or a castle. Could this be a sign of human activity? What you've just seen is known today as the Yonaguni Monument. It also goes by the name of Japan's Atlantis. The entire monument is about the size of 5 soccer fields and the height of a 5-story building. Its most surprising feature is its expanse of terraces. Explorers and scientists believe that Yonaguni might be 10,000 years old. But whether it's a human-made structure or a natural formation is still under debate. For Japan's top marine geologist, Professor Masaki Kimura, Yonaguni is the heritage of a lost civilization. Kimura has dived to the bottom of the ocean to explore the ruins over 100 times over the past 10 years. According to him, there are clear signs of human activity down there. On the monument's surface, there is a triangle-shaped concave that is a historical symbol of water fountains in the region. There's also a giant turtle carved on the eastern side of the structure. And, according to Kimura, turtles have an important cultural meaning. Several pieces of stone tools have been recovered from the site. Their estimated age is around 10,000 years. However, not all scientists support this theory. For many, Yonaguni is the result of thousands of years of erosion. The fact that the monument is composed of one massive rock leads them to believe it's not human-made. The defined edges and flat surfaces resemble a natural formation in Northern Ireland, known as the Giant's Causeway. The basalt columns look like the ruins of a palace, but they're actually the result of volcanic activity in the region. Now, you're flying to the coast of Greece, 4 hours away from Athens. More specifically, you're in the Peloponnese Peninsula. You dust off an old snorkel and head for a free dive on a bright sunny day. Sometime into the dive, you start noticing patterns on a seabed. 13 feet below the surface, outlines of familiar objects start to appear, one by one. As you continue swimming, what looks like the outline of an entire city emerges in front of your eyes. Are you wondering how water could have taken the whole city? Rocks are perfectly aligned into what appears to be the foundation of a building. This is Pavlopetri, an ancient city you've probably heard about for the first time. It was discovered by Nicholas Fleming, a British oceanographer, when he was on vacation in Greece. He had heard rumors about Pavlopetri's existence and indeed found several artifacts on the seafloor. He went back to the area a year later with the team. They found a site filled with pots, storage vessels, and tools. A kernstone, for instance, is a tool used for grinding grains and turning them into flour. Multiple amphoras indicate that this settlement dates back to the Bronze Age, 5,500 years ago, when people started living in towns. The settlement is believed to have existed for over 2,400 years. Today, Pavlopetri is considered the oldest submerged town ever discovered, and what's impressive is that it wasn't a simple village. It was a vibrant port city with stone buildings, a marketplace, streets, and even squares. The next stop on our voyage is one of today's most famous underwater cities that has been turned into an archaeological park. The city of Port Royal in Jamaica exists only below the surface, but in 1692 it was one of the wealthiest cities in the Western Hemisphere. Port Royal was the center of the British Empire at the time and an important trade city that attracted people from all over the region. It was also home to real-life pirates of the Caribbean. On the morning of June 7, 1692, the people of Port Royal met a different fate than they had probably expected. The city woke up shaking. People were thrown out of their beds by the power of a massive earthquake, ranking 7.5 on a Richter scale. One survivor said he had seen Earth opening up and swallowing the whole town. What he said could be true, as the city was mainly built on sand. The ground swallowed buildings, roads, you name it. Geysers erupted, and finally, waves as big as 10-story buildings hit the city. About 33 acres of the city disappeared under the water. Amazingly, most of its 17th century remains are still in good condition under 40 feet of water. Archaeologists have found taverns, storage rooms, kitchens, and recreational buildings used for diverse purposes. You can also see a grand lion statue, a submerged bridge, and many picturesque arches. Of course, I saved the best for last: India. Just off its coast lies another sunken marvel. A site known as the Lost City of Cambay is located in the Gulf with a similar name. It remained undiscovered until 2001, when the National Institute of Ocean Technology made a routine water assessment. With the help of sonar technology, which sends a wave sound to the bottom of the sea, they found something far beneath the surface. Images showed well-defined geometric shapes spread along a 5-mile stretch. The remains date to more than 9,500 years ago, meaning this civilization was lost at around the end of the Ice Age. Debris recovered from the site included construction material, pottery, beads, sculptures, and even bones. Scientists argue whether these artifacts are indeed from the site, but if they truly are, then the lost city of Cambay might be the oldest civilization in the world.
Okay, let's play a little guessing game, shall we? Can you name the 6th largest river on Earth in terms of volume? That's the amount of water that flows through a waterway. The first couple of rivers are easy to list. Number 1, of course, is the Amazon River in South America. Then we have the Congo in Africa, and the Ganges in India. Feel free to name all the rivers on the planet. You won't get any closer to the answer. Why? Because this river is not on the surface, but underneath the waves of the Black Sea. In 2010, a team of scientists discovered this river while studying the Bosphorus Strait in Turkey. Sonar scanning revealed a channel at the bottom of the Black Sea. The channel had water flowing through it. It turned out that at places, it's 115 feet deep. That's 3 times as tall as your average telephone pole. This flow of water acts like a real river. It has rapids and waterfalls, and its volume is 350 times greater than that of the River Thames in London. Talk about a strong undercurrent. If it was a surface river, it would really be in the top 10. Bad news for the Madeira River in Bolivia and Brazil, the present number 6. But how did this underwater river form? The answer lies in the amazing features of the Black Sea. It gets its water from two main sources. The first are the rivers that flow into it, like the Danube, Dnieper, and Don. A lot of D's there. But more importantly, they are all freshwater waterways. On the other side, quite literally, there is the Mediterranean, and it's salty, like a lot. When this salt water gets inside the Black Sea, it goes straight to the bottom. You see, fresh water is lighter than salt water. This creates stratification. It's a fancy term that simply means that the two types of water don't mix together. Salt water has a higher density, so it drops right down to the bottom. If you want to see how that works, you can do an experiment at home. Pour mineral water into one cup and salt water into another. Table salt will do. Then put a grape in each cup. You'll see how it immediately sinks to the bottom of the cup filled with fresh water. The grape will stay afloat in the cup filled with salt water. The same thing is happening inside the Black Sea. But there is another side to this phenomenon. The upper layer of water is rich in oxygen. This means it can support life. The bottom layer, however, is anoxic. Yep, you guessed it. This means there is no oxygen at the bottom. But this isn't a bad thing. Because of this trait of the Black Sea, shipwrecks are able to survive for centuries. Oxygen decomposes wood. And from what material did the ancient people make their ships? That's correct, timber. Recently, in 2018, scientists discovered the oldest Greek shipwreck on Earth. The merchant ship lies more than a mile deep at the bottom of the sea. Experts estimate that the vessel is 2,400 years old. The wreck was valuable for historians to study all the elements of ancient ship construction. From the mast to the rowing benches, it's all intact. The wreck lies some 50 miles off the coast of Bulgaria, but no one has seen it in person. Explorers sent a deep-sea ROV, or remotely operated vehicle, to film the wreckage. It was impossible for a diver to go down. But the Black Sea doesn't look that huge on a map. Could it be that deep? Oh yes, it's way deeper than people think. You could stack 6 Empire State Buildings at the deepest point of the Black Sea, around 7,257 feet. This inland sea isn't the only place on Earth where researchers have discovered shipwrecks and underwater rivers. One of the largest channels running along the ocean floor lies off the coast of South America. It runs from the mouth of the mighty Amazon and into the Atlantic Ocean. Studying underwater rivers isn't an easy task. The depth and the strong currents make it impossible to send in divers. Even the equipment for underwater research has to be sturdy. Otherwise, the current will just wash it away. That's why the underwater river in the Black Sea was ideal for scientists to explore. Earth's oceans and seas are powerful. But, lucky for us, there are places where divers can admire underwater rivers. Ever heard of a cenote? Sounds Spanish. Well, that's because it is. Cenotes are underground caves. They form after the limestone above collapses, revealing the groundwater under them. The term cenote is associated with the Yucatan Peninsula in Mexico. Ancient Maya used them as water sources. In the Mayan language, the word cenote meant sacred well. Researchers estimate there are some 10,000 cenotes spread across the Yucatan Peninsula. You can also find them in other places, such as Cuba and Australia. Beauty is in the eye of the beholder, but unofficially, the most beautiful cenote is located just south of the town of Tulum in Mexico. The name reflects the cave's divine beauty, Cenote Angelita. But people don't visit this cenote to go swimming. Its bottom is much more interesting. A scuba tank is all you need to finally admire an underwater river firsthand. The waters are dark and foggy, so divers use powerful flashlights. After a 100-foot dive, a marvelous sight appears. An underwater river with trees along its banks. Some of them even have green leaves, just like any other water flow on dry land. But it's not really a river. Here comes the fascinating part. Remember how saltwater and freshwater don't mix? Well, the river the divers see is actually a thick layer of fog between the two types of water. 3 feet of hydrogen sulfates to be exact. This is the compound that water processing plants use to remove chlorine from drinking water. The substance is so heavy that the fog it produces moves independently from the surrounding water, and it creates an illusion that a river is flowing underwater. But there are other real rivers that play tricks on you. Take, for example, the Mystery River in Indiana. It's the longest underground river in the United States. Explorers discovered the river and its cave system, Blue Spring Caverns, in the 19th century. Nearly 3 miles of the river are navigable. Isn't that impressive? You can book a boat tour on a river that you can't even see. But the most mysterious river on the planet is the Saraswati River in India. The coolest part about it is that it doesn't exist. It was an alleged river only mentioned in ancient literature. For centuries, people thought that it was just a myth. Then satellite images showed that it might be real. Ancient texts spoke of a major confluence of 3 mighty rivers, the Ganges, Yamuna, and Saraswati. The first 2 are visible today, but where's the third one? That's what scientists decided to find out. Images from an American satellite showed the presence of underground water in the area. Until then, researchers thought that these were paleochannels. This simply means that water flowed through them a long time ago. But, to their surprise, it appeared that there was still water inside these channels. Scientists estimated that the Saraswati River flowed above the ground some 5,000 years ago. But it didn't dry up completely. It just went underground, some 200 feet below the ground. Local experts believe that the river still slowly flows into the sea. The Saraswati River got hidden under the desert sand. This was a natural process, but many rivers have been forced underground because of human activity. In London, England, several dozen small and medium-sized rivers now flow under the ground. Maps from the 19th century still show them as rivers, but today they only exist in the names of the streets that were built above them, such as Fleet Street. The same thing happened in New York, but this doesn't mean that these streams have disappeared for good. When engineers want to rebuild or modify a building, they still consult city maps from centuries ago. No one wants a long-lost brook to flood their basement.
Let's test to see how many spiral-shaped objects you can find around you right now. I'll bet there's more than you think. A spiral may be hidden in the flower petals of your houseplants. One might be staring at you from that seashell you brought home from your last trip to the beach. If none of these objects sound familiar, you might want to head over to the mirror and turn to the side a bit. In case you haven't noticed yet, even our own ears are shaped like a spiral. Why does Mother Nature seem to have such a preference for this shape? Many theories wish to explain this weird behavior. One of them is based on the Fibonacci sequence. This Italian mathematician didn't really care much for spirals initially. He was studying rabbits when he came up with this theory. Fibonacci came up with the sequence as a solution to a problem involving the growth of a population of rabbits. Let's recreate his experiment. If you put a pair of rabbits in an enclosed space, how many pairs of rabbits will you find there after a year? To solve this problem, Fibonacci proposed some conditions for his theoretical experiment: that all rabbits are born as a pair, one male, one female. Also, the rabbits can start reproducing after 1 month. More so, each pair of rabbits produces 1 pair of offspring each month. And lastly, none of the rabbits kicks the bucket at the end of the year. Now, using these assumptions, Fibonacci noticed the following sequence: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. The first 2 numbers in the sequence, 1, 1, represent the initial pair of rabbits. The next number, 2, represents the number of pairs of rabbits after the first month, 1 pair of the initial rabbits plus 1 pair of offspring. The fourth number, 3, represents the number of pairs after the second month. 2 pairs of the initial rabbits plus 1 pair of offspring, and so on. He soon noticed that his series is made out of numbers in which each number is the sum of the previous 2 numbers. A lot of other mathematicians have looked at this sequence over the years. They were soon surprised to discover that this system was found in many natural structures, such as the arrangement of leaves on a stem and the arrangements of seeds on a sunflower. If you don't understand why it is so, then grab a piece of paper and a pen. Together, let's try to draw the Fibonacci spiral. You'll have to start with a small circle at the center of your page and then draw larger circles around it without lifting the pen from the paper, using the numbers from the Fibonacci sequence. For example, the first circle is 0 units wide, the second circle is 1 unit wide, the third circle is 1 unit wide, and so on. As you keep adding more circles, they will fit together perfectly to form a spiral shape. The spiral gets bigger and bigger, but it always follows the same pattern based on the Fibonacci sequence. Another famous spiralist was a man named James Bell Pettigrew. He was a Scottish naturalist that became fascinated by the mystery of the spiral shape, which he noticed almost everywhere in nature. He studied it at all scales, from giant nebulae in space to tiny molecules. Despite his research, he couldn't figure out where the spiral came from. He was sure that it couldn't be just a physical thing, and he believed that organs in plants and animals are not only shaped like spirals, but they also work in a spiral way. At the center of lifetime work on this unique shape was the human heart. Pettigrew believed that the heart's spiral structure was the mystery of all mysteries. He also thought this shape was to blame for both its muscular contractions and how the blood seemed to travel within our mighty tickers. The reason why the spiral seems to be everywhere might be really simple: efficiency. Take a look at the basic sunflower, for example. It figured out a way to display its seeds so that it could expose them to the sun equally, without wasting any space and without being limited in their growth. Spiral stairs are another great example too. They just work better. You find it easier to climb them, and they should take less space than the usual ones. We also might be more inclined to notice this shape more than others. That's because a spiral shape, or its proportions, is more aesthetically pleasing to the human eye. It's the reason why interior designers, artists, or illustrators often use these principles in their work. The spiral symbol is also the oldest symbol found in every civilized continent. Some historians believe that the spiral in Asian art may represent the sun, as it has been found on roof tiles from the Tang dynasty near the ancient city of Chang'an. It is also often found at burial sites, and scientists believe it to represent the circle of life, how we pass on and somehow be reborn. This is probably because in some ancient civilizations, people believed that the sun was born each day, extinguished itself each night, and was reborn the next day. You might have also stumbled upon the spiral as a symbol of hypnosis and dizziness. There's no real evidence that you can hypnotize someone by making them stare into a spiral for a certain time. But its effects on our abilities to focus and our optic nerves are significant. After you've stared at a spinning spiral for quite some time, you'll notice how objects either get smaller or bigger, depending on the direction of the spiral. It's easy to understand why some experience the sensation as hypnotizing. One of the most distinctive features of DNA is its spiral shape. It's also called a double helix. The double helix is formed when 2 strands of DNA twist around each other, like a ladder being twisted into a spiral shape. This spiral shape is important for many reasons. First, the spiral shape allows DNA to be compact and efficient. The double helix can pack a lot of genetic information into a small space, making it possible for cells to store vast amounts of genetic material in a small area. Second, the spiral shape allows DNA to be flexible and respond to changes in our environment. Because the double helix is made up of 2 strands that can move relative to each other, our DNA can change its shape. Finally, the spiral shape of DNA allows it to interact with other molecules in the cell. Now, let's look at the big picture. I mean, the biggest of them all, that of the galaxies found in our universe. They're also shaped like a spiral due to their rotation and the presence of dark matter. As the galaxy spins, the stars and gas clouds within the galaxy move in a circular direction around its center. This movement creates a spiral shape as the stars and gas clouds are drawn toward the center of the whole system. Additionally, the presence of dark matter, which is a type of matter that does not interact with light, creates gravitational forces that help to shape the galaxy into a spiral. But you don't need to look that far to understand why spirals are important. Your handy corkscrew is shaped like a spiral too, because it makes it easier for you to open the wine bottle. That screw you drilled into the wall to hang a picture, also a spiral. It helps it with some added grip and stability. Got a notebook on your desk? Those pages might be held together by a spiraled wire. It makes it easier for you to browse the notebook without damaging the pages. Even your hair strands might have a curled shape. The curlier the hair, the drier it will be. It means it will get sebum from the scalp down on the strand slower, making it easier to maintain and clean. And before I spiral out of control, we're done here.
Have you ever wondered how the world will go down in flames? Will it be due to zombies, extraterrestrial civilizations, or AI taking over? Nah, turns out it might actually be mosquitoes and scientists causing the chaos. It's funny how things created by nature aren't as threatening as the stuff that doesn't exist naturally. And you know what's on that list? Editing the DNA genome. Experiments with the genetic structure of living organisms can produce completely new species, and no one knows how nature will react to them. Let's look at an example of gene drive. So it all started with malaria mosquitoes. To somehow stop the growth of their population and prevent the spread of malaria, scientists created a gene that magically made mosquitoes only have male offspring. Several insects with this gene transmitted it to others during the mating season, and thus spread infertility. Scientists were able to stop malaria and destroy almost the entire mosquito population. But imagine if something went wrong in the mosquito genome and their population began to increase exponentially. Malaria could spread across all continents and create huge problems for all of us. Now, let's move from the little mosquito problem to a planetary disaster that can be caused by the desire for knowledge, which is deeply embedded in our nature. British cosmologist Martin Rees once said that we lived in the 1st century when human beings could determine the planet's future. It seems that it's so easy not to destroy yourself, but our nature is quite complicated. In pursuit of solving the mysteries of the universe, we have built a giant machine that, according to some people, may destroy our planet. And this device is the Large Hadron Collider. The main task of this giant machine is to accelerate particles and make them collide with one another. Scientists expect that the collider will help better understand the structure of our universe. In simple words, this is a miniature simulator of the universe. Using it may also shed light on the mystery of dark matter. During operation, the machine compresses atoms and makes them crash into one another at great speed. Perhaps this is how our universe appeared. Some people fear that a small black hole may form because of this collision. A tiny particle with a huge weight will pull all objects inside itself. Its mass will grow, but its size won't change much. As a result, it will compress the entire Earth and turn it into a ball measuring a little more than 300 feet across. At the same time, our planet will still have the same weight. A powerful gravitational pull on such a small area of matter can form a black hole that might later swallow up our entire solar system. There are also theories that the Hadron Collider could open a portal to a parallel universe with creepy monsters that would enter our world. But of course, such theories have little to do with science. Scientists have already launched the collider several times, and as you can see, nothing terrible has happened. But there is a small nuance. With each launch, scientists increase the speed of particles. Who knows what will happen when they accelerate them too much? According to Martin Rees, the probability that Earth will become a black hole is very, very small. Particles with a much larger energy charge fly in space faster than in the Hadron Collider, and nothing catastrophic happens. Okay, now let's go back to our genomic games to see what else can happen if we continue experimenting with nature. The main problem might be an imbalance in ecosystems. In the 19th century, sailors accidentally brought mice to Gough Island in the South Atlantic Ocean. Rodents had no dangerous enemies there, so their population began to grow. Mice began to displace dozens of birds from their home. The rodents attacked the chicks and reduced the population of entire species. Trying to save the birds, scientists decided to get rid of the mice, but these little creatures still managed to survive. As a result, the balance of the whole ecosystem was disrupted. Using gene drive to get rid of one species can lead to uncontrolled population growth of another. Imagine that malaria mosquitoes controlled the population of some flies. And what would happen if these flies lost their main natural enemy? The population of these flies would start destroying other species, and it would begin a chain of destructive events. All this suggests that playing with things that don't exist in nature is very dangerous. We worry a lot about how artificial intelligence can take over the world and eliminate us. Still, at the same time, we don't pay attention to our actions. Genome editing can lead to positive consequences, such as the appearance of healthier people, and destructive ones, like the creation of artificial bacteria that can cause serious health problems. In general, destroying other species is a trait inherent in humans. Because of our actions, many animals have disappeared from the face of the earth. Moreover, we even destroy each other. Such aggressive behavior is our nature. And artificial intelligence doesn't have anthropomorphic properties. Its logic may be completely different from ours, and instead of destroying people, it might strive to save them. And we have something to save us from. Remember the giant asteroid that erased more than half of the living creatures on Earth? The fall of the space rock caused a massive blast wave, a tsunami, earthquakes, and dust clouds that covered the sun. Dinosaurs and other animals couldn't survive in such conditions. But what if something similar happens these days? Fortunately, we're better prepared than dinosaurs. Firstly, we have the technology to track giant meteorites and calculate their trajectory. And artificial intelligence can also help us with this. Secondly, we can destroy an asteroid before it reaches us. Several powerful rockets will quickly deal with any space rock and turn it into cosmic dust. Moreover, we will know in advance about its approach. But suppose that a huge stone the size of dozens of Everests will fly towards us. In that case, humanity should hurry with Mars colonization. But don't worry. Observing the sky shows that large asteroids capable of causing severe damage to our planet are moving in a different direction. The most giant known asteroid that could collide with Earth might do so in 2088. The probability that it will fall on our planet is 1 in 50,000, so you shouldn't have to worry about threats from outer space. What lies in the bowels of our planet is much more dangerous. Millions of tons of magma and hot gases can burst to the surface through destructive volcanic eruptions. More than 70,000 years ago, a large-scale eruption threw a tremendous amount of ash into the air, which then floated in the atmosphere in the form of a giant gray cloud for a long time. As a result, Earth's surface cooled down by several degrees, which led to one of the most massive extinctions in the history of our planet. Some eruptions happen not only inside volcanoes. There's such a thing as flood basalt. A colossal magma bubble accumulates under a vast area and begins to seep through faults in different parts. Magma slowly goes out there for many years and destroys all living things around. And the worst thing about this situation is that we can't do anything about it. Humanity has learned to track meteorites in space, but we're still not good at predicting a volcano's behavior. Even if we find out that some giant rock will wake up in the next 6 months, there's nothing we can do about that. We won't be able to prevent an eruption. All we can do is evacuate people from dangerous territory. We have no protection against earthquakes, and even more so, we can't stop the emission of ash into the atmosphere. It's possible that artificial intelligence will help us with this in the future, but right now, we're powerless. As you can see, there are several options for the end of the world for humanity, and they're all slightly different from those imposed by pop culture and the media. In the end, Is it right to look for threats from space or artificial intelligence? Look at this spatula. Just a regular tool, mix and spread ingredients, right? But wait, this one is floating in space for some reason. So there's this astronaut named Pierce Sellers. There he is. He's up there in space, just doing his thing, when all of a sudden, he accidentally drops his trusty spatula. Let me give you some context. This all happened during the Space Shuttle Discovery's STS-121 flight back in 2006. They were on their way to the ISS on a mission to test out some new safety techniques. And now this spatula is just a tiny drop in the ocean of space debris. Humans have been exploring space for over half a century now. We've left all kinds of random stuff up there, from itty-bitty bolts to entire space stations. We've chucked a ton of things into the great beyond. Most of it burns up in a spectacular blaze as it re-enters Earth's atmosphere. But some bigger pieces can be a real danger for astronauts and their fancy spacecraft. Imagine accidentally crashing into a massive hunk of space junk. There are other weird things found in space. In November 2008, astronaut Heidi Stefanishan Piper was out on a spacewalk trying to fix a jammed gear on a solar panel. Suddenly, she lost her grip on the bag. That bag weighed around 30 pounds and was filled with all sorts of cool stuff, like grease devices, a scraper tool, and bags for debris. And it was pretty pricey for a tool bag. It cost around $100,000. Sometime later, amateur astronomers spotted the bag floating around in space. If you're in North America, you can even check if the tool bag is passing through your little slice of the sky. Just hop on over to spaceweather.com's satellite tracker and see if you can catch a glimpse of this interstellar tool bag. By the way, if you need to twist some wires in space and you don't have pliers, well, you may stumble upon them as they're free floating in space too. Back in the day, when astronauts were just getting their space groove on, they tended to misplace things up there. During his first spacewalk on the Gemini 4 flight in 1965, Ed White, a famous spacewalker, accidentally let go of his glove. That glove decided to have its own adventure and hung out in orbit for a whole month before getting roasted in Earth's atmosphere. So not all debris is there to stay after all. So, space junk is basically all the stuff floating around in space that humans have left behind. Before we got all curious and started exploring, there wasn't any space debris hanging around. Imagine space junk as a little kid who just learned how to walk and play with their own toys. When they couldn't walk yet, it was easy for the person watching them to keep the play area clean. They were in charge of taking out the toys and putting them away. But now that the kids can walk, they can grab as many toys as they want and make a huge mess on the carpet. Well, it's kind of the same with us humans exploring outer space. We've sent all sorts of cool gadgets, like cameras, rovers, and rockets to check out what's out there. But we haven't really thought about bringing them back to Earth. And that's where the problem comes in. All this space junk floating around could mess up outer space, and even our planet. When we think about outer space, we often imagine vast open spaces that are yet to be fully explored. Humans have only discovered a tiny 5% of the universe. But here's something they might not always consider: the impact of all the cool gadgets they send out there. Believe it or not, as of May 2022, we've got more than 5,000 satellites orbiting Earth. Over 5,000 opportunities for these machines to go haywire, get lost in space, or even worse, create a bunch of debris that could harm both outer space and our lovely planet. There's at least 3,000 satellites just hanging around up there, not doing anything useful, and nobody seems to be bothered about bringing them back home. And what if one of these inactive satellites accidentally collides with one of the thousands of other space junk pieces orbiting our planet? It will result in a catastrophic disaster. We're talking about a crazy release of toxic substances that could wreak havoc on our poor Earth. Space junk can mess things up for scientists trying to make important discoveries. It's not just floating around aimlessly in space or posing a threat to Earth. It can hinder their chances of success. Even the moon has its fair share of junk, which Neil Armstrong definitely didn't encounter when he landed there in 1969. Think of it like this. Imagine you're an artist trying to create a huge painting. It's hard to do that if there's a bunch of old paints, brushes, and other stuff cluttering up your play area, right? Well, it's the same deal for scientists trying to set up camp and use new technologies for advanced missions and space exploration. They need a clean and organized space, just like you need a tidy work area. Otherwise, it's chaos. So here's the deal with space junk. It's not just about sending stuff up into the atmosphere. It's also about how far away we send it. You see, when satellites are sent over 22,000 miles into the atmosphere, it becomes a real problem to retrieve them and bring them back to Earth. And that leads to even more space junk floating around up there. Now, I know what you're thinking. How long will it take for space junk to become a major problem? Well, it might still be a few more years before it messes things up in outer space. But hey, that doesn't mean it's not a threat to satellites we have up there right now. Those poor guys are at risk of getting damaged, destroyed, or even leaking toxic stuff because of all that junk. So, space debris isn't just a problem for space exploration, but it's also a problem for us Earthlings, even though it's floating thousands of miles above us. Space junk is like that annoying neighbor who throws trash out their window and it ends up in your backyard. Except instead of trash, it's releasing all sorts of chemicals into our atmosphere that are slowly destroying our precious ozone layer. It can even ruin future space missions. Imagine this. You're all pumped up to launch a rocket into space, but nope, space junk decides to crash the party. Not only does it mess up the launch, but it also adds more pollution to our already struggling atmosphere. And if things couldn't get worse, imagine a shooting star or meteor accidentally smacking into some space junk on its way to Earth. Boom! Millions of toxic particles raining down on us, further depleting the ozone layer. Plus, space debris is becoming a real problem for space missions. In 2022, we found some space debris hanging out on Mars. The Perseverance rover stumbled upon its own back shell, just chilling on the surface of Jezero crater. They also spotted a random piece of a thermal blanket that might have come from the rover's descent stage. Also, human-made space debris actually smacked into the moon in 2022. It was probably some old rocket body from the 2014 Chang'e 5T1 mission, but nobody saw that coming. It left a double crater behind. The more space junk we have floating around in low Earth orbit, the higher the chances of a cosmic collision. These collisions are no joke. They've already caused some serious satellite damage. Even the ISS has to constantly maneuver to dodge space debris. But scientists seem to know how to clean up this orbital mess. They're planning to send space vehicles armed with nets, harpoons, and even robotic arms to capture and deorbit all that junk.
Let me take you to a place that seems to be out of this world. Life inside this cave has been isolated from the outside world for about 5.5 million years. And it does show. See for yourself. Due to such a long isolation, the conditions inside the Mobile Cave are like nowhere else on our planet. A unique ecosystem is flourishing there, even though there is a severe lack of sunlight inside the cave, and the air is toxic. The cave, located a few miles west of the Black Sea in Romania, was first discovered in 1986. Nowadays, you can only visit it if you have special permission. Plus, the central caverns are guarded naturally by narrow limestone tunnels and vertical shafts. So, if you're no stranger to claustrophobia, you'd probably better not enter this place. In the depth of the cave, the air has twice less oxygen than the air outside. Instead, it contains a lot of carbon dioxide and hydrogen sulfide. So not the freshest air you can breathe. It's also pitch black inside the cavern. But despite, or should I say thanks to, this cocktail of extremely harsh conditions, the site is a true goldmine for biologists. Shockingly, life seems to be booming here. In a 1996 study, scientists identified 48 species, and 33 of them were unique to the cave. Most of the creatures inhabiting the cave are tiny, with long limbs and antennae that help them navigate in the dark. They have no vision and lack pigment, and it makes sense. Why would you need to be able to see if you live in total darkness? And why would you need to be pretty and colorful with no one to see you? Now, I'm going to take you to another cave. It's no less amazing, but looks very different. This is the Giant Crystal Cave, aka the Cave of the Crystals, in Mexico. These ginormous crystals were found in 2000 by a mining company after the water was pumped out of the cave. 2 miners then saw the crystals after entering the drying cave on foot. These awe-inspiring crystals are actually massive gypsum pillars hidden 984 feet underground. They're anchored to the walls and the floor of the scorching hot cave. Scientists estimate that the crystals could have been already growing for 500,000 years. That's why many of them are so long and wide that you can walk across them. Unfortunately, visiting this wonder of nature is impossible at the moment. But maybe it's for the better, since the Giant Crystal Cave is a dangerous place that can easily turn into a trap. For tens of thousands of years, it was filled with groundwater, which was originally pushed upward into the opening by a magma chamber located in the depths of our planet. The magma under the cave kept the water hot, but eventually the temperature of the water dipped below 136 degrees Fahrenheit. As a result, the water started to fill with calcium and sulfate, whose particles began to recombine into gypsum. And then, white-tinted crystals took over the cave. And since they stayed underwater, they were able to keep growing. You don't have to fly to space to take a closer look at a black hole. Scientists have found something very similar to black holes in the southern Atlantic Ocean. A black hole has such an enormous gravitational pull that once something gets pulled inside, it doesn't have any chance to escape. Even light can't get out of a black hole. But ocean black holes seem to be almost as powerful as their space relatives. But instead of catching the light, they do the same with water. Ocean eddies are massive whirlpools that spin against the main current. They usually swirl billions of tons of water, and most of them are larger than a city. These whirlpools are so powerful that nothing trapped by them can escape. But the scariest thing is that you might not even notice heading into one of them. These things are so huge that you won't spot their boundaries until it's too late. When scientists started exploring ocean vortices with the help of satellites, they discovered the borders of several eddies. After that, they managed to prove that, mathematically, these whirlpools are the same as mysterious black holes in space. Massive eddies are surrounded by super-tight barriers where fluid moves in closed loops. Even water can't get out from the inside of these loops. That's why tight ocean vortices play the role of enormous containers. Water inside them can be totally different from the ocean surrounding an eddy. And I'm not only talking about its temperature. The salt content inside and outside a whirlpool often differs as well. On the thin Curonian spit splitting the Baltic Sea from the Curonian Lagoon, there is one of the most bizarre places on Earth. Locals call this area the Dancing Forest because pine trees in this forest have shockingly unusual shapes. They twist in spirals and circles along the ground. There are some theories why it could be happening, of course. Some people claim that huge amounts of positive and negative energies once clashed in that spot. More down-to-earth individuals believe that the reason is geological. Sandy soil in the area is too unstable to hold trees growing upright. The most popular is the idea that strong winds blowing from the water influence the shape of the trees. In any case, experts haven't come to the final conclusion yet. Look at these underwater crop circles. For the first time, they were spotted in 1995, close to southern Japan's coast. Local divers called these 7-feet-wide structures mystery circles. The enigma had been plaguing many minds for almost 16 years until the culprit was finally caught. Imagine the researchers' surprise when it turned out to be a male pufferfish. The fish needs a bit more than a week to build one circle, and the aesthetics are obviously crucial. A male is swimming inside the circle, digging valleys in the sand with its fins. But that's not all. The fish also use shells and corals to decorate particular parts of their circles. This whole build-a-circle thing has a practical purpose as well. The way a male fish swims pushes the sand toward the center of the circle and creates a mound which later serves as a nest. The next mystery on our list is in the Caribbean. Just off the coast of Belize, there's a giant sinkhole. That's the Great Blue Hole. It's about 1,000 feet across and more than 400 feet deep. Once, a long, long time ago, this hole was a cave. But then rising waters filled it, making it collapse in on itself. The deeper you'll descend into the Great Hole's crystalline waters, the darker it will become. You'll see tons of stalactite-filled caves there, but entering them is extremely dangerous, unless you want to get hopelessly lost. Once you reach a depth of 50 feet, you'll notice that the water is shimmering. That's the invisible line dividing the sinkhole's salty top from the freshwater abyss. You might want to turn back right now. Who knows what you might come across in the murky depths. There was an old Amazonian legend that told about the river that was so hot that it boiled. And it was believed to be just a legend until Peruvian geoscientist Andres Russo questioned if the river could be real. All experts denied such a possibility. After all, hot rivers do exist, but only in the areas where there are volcanoes. As for the part of the country mentioned in the legend, there are no volcanoes in that region. But Andres Russo was too dedicated to give up. And in 2011, he finally located the river from the legends. The water in it was indeed steaming hot. Its temperature was 186 degrees Fahrenheit, not boiling, but pretty close to this point. But what shocked the researcher the most was the size of the river. One could think that the almost boiling water was the result of the activity of an underwater hot spring. But thermal pools are always small, while the river is 20 feet deep and flows for almost 4 miles. This is the only river of its kind on our planet.
The Earth has 3 main layers. 2 parts of the core, the dense, hot inner core, and the molten outer core. Then comes the mantle. And then follows the thin crust, the surface that supports life as we know it. At least, that's what we thought, because now scientists found a new mysterious layer located deep within the solid inner core. Earth's inner core is approximately 2/3 the size of the Moon. And made of nickel and solid iron, it's burning hot. The temperature at the center of our planet is the same as at the surface of the Sun. The outer core can reach almost 10,000 degrees Fahrenheit. It's difficult to explore it because we can't go there, and it's like looking through a really dirty window of 3,200 miles of molten metal and rocks. But we can rely on laboratory experiments on heated pressurized rocks, signals from seismic waves, and computer models. When an earthquake hits, it sends out seismic shock waves. Those waves travel through layers at a different speed, depending on the direction they go and the material they move through. In the new study, a team of scientists set a data set of 100,000 deep earthquakes. Some of them went over 60 miles below the surface. When an earthquake happens on one side of our planet, scientists track its waves all along to the other side. Waves change when they come to the other side, so scientists try to understand the materials these waves have passed through. They found a new layer in the core of our planet thanks to earthquakes. Normally, shock waves travel along the equator, but down below, they digress and go into different directions, about 60 degrees to the side. When waves pass through the inner core going from north to south, they will travel more quickly than waves going through the core parallel to the equator. It's important to understand the core because it creates our magnetic field, which, in turn, protects the planet from things like solar winds that are charged particles coming from the sun. In the 1960s, we discovered the Earth pulsates every 26 seconds. It's like clockwork, a giant heartbeat. The ground is slightly shaking, but we mostly don't feel it. Researchers can still track it. Some of them think the continental shelf comes as a huge wave break under the oceans. For example, the highest part of the North American continent falls off into a deep abyssal plain. One theory says waves hit this spot, producing regular pulses. It's like having all kinds of drums. You hit them with your hands and accidentally slam that one spot that produces the right harmonic bang to rattle our entire planet. If this theory is true, we're lucky there are no more spots like this that can shake the Earth. Other scientists believe the pulsation happens because there's a volcano near the critical spot, the island of Sao Tome in the Bight of Boni. You're walking, running, and jumping, but when you stop, it always feels like you're standing still. In reality, You're moving, even when you're perfectly still, because our planet is always on the move. Depending on where you're at, you could be spinning through the universe at more than 1,000 miles per hour. If you're on the equator, you'll move the fastest. Let's say you have a basketball spinning on your finger. Check the ball's equator. A random point on it has farther to go in just one spin than any point near your finger. That means the point on the equator is moving more quickly. The Earth is a planet that recycles all the time. The ground we're walking on is recycled. Our planet's rock cycle turns rocks of one type into another. That's a cycle that goes on and on. The depths of our planet are filled with magma. As magma is going out onto the surface, it hardens into rock. Tectonic processes like volcanic activity, earthquakes, mountain building, and all of the other processes that shape the surface of our planet bring that rock to the Earth's surface. When the rock is on the surface, erosion shapes it and shaves its bits off. Those small particles then get deposited. All the pressure coming from above compacts the particles into sedimentary rocks, like, for example, sandstone. Sedimentary rocks can also end up deeper and deeper under the Earth's surface. Since there's a lot of heat and pressure, they get cooked into metamorphic rocks. They can go back to the surface once again, or even end up being re-eroded. Sometimes the crust plates are pushing one under another, and this way, rocks can transform into magma once again. We've explored only 5% of the ocean so far. The ocean itself, as well as life below the seafloor, is still a mystery. The sediments that are underlying our oceans are home to different microorganisms that exist even at depths of 1.5 miles beneath the seafloor. There are microbes hidden deep inside volcanic rocks below the seafloor off of the parts of the Pacific, hidden under 870 feet of sediment. The biosphere under the seafloor is growing extremely slowly compared to life on the surface. Cell division happens every 10 to 1,000 years. Something's different about the Earth's axis. Climate changes and melting glaciers, mostly in the regions like the Himalayas and Alaska, made the axis shift. Our planet has two kinds of poles. Are the south and north magnetic poles. They affect things such as drift and navigation. The axis that the Earth is spinning around is another kind of pole. It shifted a little bit over time, but we don't know exactly why. Researchers realize there are moving masses of water, pushing the Earth's axis eastward. Take a basin of water as an example. If you're moving it back and forth, sloshing makes the water move its weight all around. A similar thing is happening on a planetary level. No matter how large an earthquake is, no human could ever feel an earthquake on the opposite side of the Earth, although some people claim they did. In 2013, there was one near the Kuril Islands with a magnitude of 8.5. It went around 400 miles deep. It was so strong, people in Australia reported they could feel the ground shaking. The strongest earthquake happened in Chile in 1960 with a magnitude of 9.5. The rupture zone stretched from 311 miles to almost 620 miles along the country's coast. Earthquakes with a magnitude of 10 or higher can't happen. The magnitude depends on the length of the fault where it occurs. The longer the fault, the bigger the earthquake. A fault is a break in a part of the planet's crust. It has rocks on both sides, and they move past each other. We haven't found a fault long enough to generate earthquakes with a magnitude of 10 or more. If it happened, it would extend around most of our planet. An earthquake with a magnitude of 12 would require a fault larger than our planet. One side of our planet is getting colder than the other. The Earth has a system that keeps it warm from the inside, a red-hot liquid interior deep below the surface. It spins and, at the same time, generates a magnetic field and gravity. That way, the Earth's core holds the atmosphere closer to the planet's surface. The Earth also absorbs heat from the sun, mostly on the surface. The heat doesn't spread equally on all parts of the Earth. One side of the planet, the Pacific Hemisphere, is losing heat more quickly than another, the African Hemisphere. This happens because land traps more heat than the surface under the ocean. The seafloor is way thinner than the landmass. Also, the temperature caused by the heat coming from inside the Earth is getting lower because of huge amounts of cold water above it. Clouds are not just like some fluffy distant pieces of cotton. They weigh more than 1 million pounds and help regulate our planet's temperature. If you take all the water droplets in clouds and bring them to the surface, you could cover the planet with a liquid layer as thin as a human hair. It doesn't seem like a lot, but this water is crucially important for climate. We'd have warmer temperatures if it weren't for the clouds.
Back in 2018, the biggest active underwater eruption ever happened, at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults. which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit. But the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink seawater. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams lived long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps. Each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
Our Sun. Scenario 1. Something strange just happened now. Every TV channel, the news, they're all talking about a black hole that came closer to us, on the spot where our Sun used to be. You can even see an accretion disk, and the background of the sky looks kind of distorted, which means it got really close. Normally, black holes are so far away that we can't see them with the unaided eye. You can't even see them with a telescope directly. What's it doing here so close? And where's the Sun? Did the black hole swallow it? The Sun used to be in the center of our solar system, far enough not to burn us, but still close enough to give us light, warmth, and beautiful scenes when it rises in the east and goes to rest in the west. Hey, this one even rhymes. Well, it gave us life. The most massive body in our solar system contains 99.8% of its total mass. It's so wide, you could fit more than 1 million Earths inside of the Sun. Maybe our Sun turned into a black hole, but it's way too early for that to happen. I mean, that's how they form. When enormous stars come to the end of their life cycle and explode, which is called a supernova, they end up collapsing on themselves, becoming very small. It's a tiny size and a huge mass. That's what makes black holes' gravity so strong, and even light that comes too close can't escape. And all the stars in the universe are shrinking and will disappear at some moment. Our Sun loses 4 million tons of mass every second, and eventually, the only energy left in the universe will be generated by black holes. A black hole is surrounded by dust, gas, and radiation. The radiation is very dangerous, so we hope our planet won't come near it. Our solar system doesn't have light anymore. No light and no heat either, so even Mercury and Venus will probably get covered in ice pretty soon, not to mention Earth. Do I need to say nothing will survive this new ice age? The only salvation might come from the accretion disk that spins so fast it generates heat, but that's too many chances to take. Still, at least if the black hole has the same exact mass as the Sun before it, all the planets will remain in the same orbits, Earth included. But if it has a mass bigger than our Sun, which is something our scientists are currently trying to figure out, then bye-bye, solar system. It was nice knowing you. Scenario 2. Oh no, what's happening? It was supposed to be a nice sunny day, but now you see darkness descending so abruptly. How come it's night, yet the clock says it's 2 p.m., and the moon looks different? The TV reports say our Sun is gone, and due to some mysterious events, the moon is not orbiting the Earth anymore. It's in the center of our solar system now. We don't have much time left. Since the Sun is not in the center of our solar system, we now have 8 minutes and 20 seconds to become aware of it. It may take millions of years for the Sun's energy to travel from its core to the surface, but 8 minutes and 20 seconds is exactly how long it takes for sunlight to reach Earth. The light takes a journey across 93 million miles, which is the distance that separates us from the Sun. We're not in the habitable zone anymore. The habitable zone is the distance from a star, in our case, the Sun, at which liquid water could exist on the surface of a planet. Now that the Sun's gone, its light won't reach us anymore, and our planet will gradually become a frozen, lifeless rock. Who knows if we'll have enough time to come up with some technologies that would provide us with the solar energy we need to sustain life on Earth. If not, well, millions or billions of years later, scientists from some other civilizations would explore it, trying to find evidence if life ever even existed there. It would be the same as we do with Mars and other planets in our solar system, trying to figure out if they've always been lifeless or if there might be a sign that some organisms used to live there. Something else, also vital for our life, travels at the speed of light. Gravity. Without the Sun, for roughly 8 more minutes, the planets would continue circling the empty center of our solar system, until the clock ticks and they finally drift somewhere into an unknown direction of outer space. Our moon doesn't have a strong enough gravity to keep us in place. It can't shine so brightly to give us warmth and support life. It's so far, we can barely see it now. Without the moon that peacefully travels close to our planet as it used to, we can see tides are getting lower incredibly fast. Oh, and it's becoming really windy. Winds are so much stronger and faster now. When things were normal, our planet sat at a 23.5 degree tilt, which is the reason we had changing weather and seasons. Now the tilt is so extreme, it's getting very cold, very fast. And our time is almost up. People are screaming, everyone's in panic. We still have maybe 1 minute left until we sink into eternal darkness. Scenario number 3. We're not sure what exactly happened and how the life we carelessly lived yesterday came to an end. No one could predict it, but it seems that, out of nowhere, a giant neutron star took the spot where our sun used to be. It's not something we'd recognize on our own. We just noticed something was different, and the sun kinda got smaller and weirder. The rest we heard on the news, and no one knows how it happened. Maybe our sun is somewhere behind the neutron star, or the star pushed it out of our solar system and into an unknown direction. A neutron star is the densest space object we know about. It has almost twice as much mass as our sun, but it's all squeezed into a star only 10 miles, 15 kilometers, across, which is about the size of a city on Earth. A neutron star forms when a huge star runs out of fuel. It collapses in a big explosion. Its very central region, the core, collapses, which is why every electron, negatively charged particle, and proton, positively charged particle, crush together into a neutron, which is either uncharged or neutrally charged. We're in a very tricky situation now, basically waiting for our end to come. This neutron star has gravity 2 billion times stronger than the one Earth has. This means our new sun will pull all the planets in our solar system towards itself and eventually destroy them. It's already started. For the first time that we know of, the planets are leaving their stable orbits, attracted by the powerful force of the neutron star. It's becoming chaotic pretty fast. And it won't stop there. A neutron star rotates more than 700 times every second, which is incredibly fast. Our sun rotates once every 27 days. So, after it destroys all the planets, including us, this star will continue whirling throughout the universe at about 1/5 the speed of light. Maybe it will slow down and fizzle out with time, but maybe not. After thousands of years, many neutron stars begin to slow down and blow out. But that doesn't always happen. If it meets another star, it will orbit it and start to feed off its atmosphere until it collapses at some point and turns into a giant black hole. Our sun was going to burn out anyway. Until the neutron star showed up, the sun was 4.6 billion years old, which was about halfway through its lifespan. It had already burned off about half of its hydrogen stores and had enough supplies for another 5 billion years. It was eventually supposed to end up the size of the Earth. After running out of fuel, it would have simply collapsed. It would have retained its enormous mass, but its volume was going to be similar to that of our planet. No sun, no life. So the result would have been basically the same. But this way, it would have been a slow process. Who knows if humans would even inhabit this solar system in those times? But with neutron stars, things move towards the end pretty quickly, and it's way more chaotic. If the neutron star was going crazy somewhere far away in another galaxy, we'd only see it in the shape of a distant flashing light that we call a pulsar. But this way, boom!
At a distance of 640 light-years from the Sun, scientists discovered planet WASP 76b, where it rains iron. The planet is very close to its Sun and always turned to it in the same side. The term is tidally locked. The temperature on the sunny side is so high that metals melt and evaporate there. The other half of the planet is cool enough so that metals condense again and fall down as rain. Speaking of tidal locks, our moon is the same way. There's no dark side to our satellite, it's just always turned to us with one side. When the moon happens to be in between the Earth and the Sun, what we call its dark side becomes brightly lit. We just can't see it from our planet. Figures. A recent study claims that the moon has a tail, and every month it wraps around our planet like a scarf. A slender tail made up of millions of atoms of sodium follows Earth's natural satellite, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. You won't believe it, but the moon seems to be shrinking. Earth's natural satellite is now 150 feet smaller than it used to be hundreds of millions of years ago. The reason for this phenomenon might be the cooling of the moon's insides. It could also explain the quakes shaking the surface of our planet's natural satellite. Astronomers have recently found out that Mars is seismically active. Mars quakes occur there on a regular basis. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks up that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But on those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the moon's full diameter. Turns out there are plenty of planets in the universe, and even in the Milky Way galaxy, that have liquid or frozen water on them. The closest one is within our solar system. It's Europa, one of Jupiter's moons. Scientists are almost sure that underneath its frozen surface there's an actual ocean of water. But it's too soon to be hyped about possible life on such planets. Liquid water is only one of many things that have to come together for life to appear on a planet. A star in the galaxy GSN 069 is likely to turn into a planet the size of Jupiter in the next trillion years. It might happen because of the star's regular encounters with a black hole. First, astronomers noticed unusual X-ray bursts that were strangely bright. They went off every 9 hours. After studying this phenomenon for some time, the scientists realized it was a star moving in a unique orbit around a black hole. The dazzling flashes? It was the material getting slurped off the star's surface by the black hole. It turned out that over millions of years, the black hole had already transformed the red giant into a white dwarf, and the process isn't going to stop whatsoever. Astronomers have found some traces of phosphine in the atmosphere of Venus. On our planet, this gas, colorless and flammable, is often found where microbes live. No wonder a new theory suggests that there might be life on Venus. But even if there was some life on the evening star, it could have only appeared in its atmosphere. Probably no living organism would be able to survive the planet's extreme environment. Venus's surface is extremely dry. There's no liquid water on the planet, and the pressure there is 90 times greater than that on Earth's surface. The temperatures often rise higher than 900 degrees. That's hot enough to melt some metals. As for vacations there, I'll pass. In fact, there's a place millions of light years away where there's a whole floating space cloud made entirely of water. There's so much of it that we could fill all our oceans 140 trillion times over, slightly more than what we need. Water on Earth is actually a puzzle shrouded in mystery and covered with riddles. The most popular theory is that it was brought to our planet by icy comets and asteroids that left behind not only mighty craters, but the liquid substance thanks to which we can now thrive. But in space, there's a whole lot of organic matter, and under specific conditions, it could yield so much water it would be enough to fill our oceans thousands of times over. Researchers conducted an experiment in which they heated this organic matter and obtained clear water and oil. If this is confirmed in future studies, it could mean that even oil appeared on Earth not only thanks to fossilized remains of living beings, but came from outer space as well. And yet, there might just be about 6 billion Earth-like planets in the Milky Way galaxy alone. The latest data has shown that every fifth Sun-like star can have at least one planet in its habitable zone. And not just any planet, mind you. It has a rocky core and surface, and it's of comparable size to the Earth. Being inside the habitable zone of its star, such a planet would have high chances of becoming home to living creatures, microbes at least. And if there are billions of these planets in our galaxy, you could safely say that at least one of them is not only habitable, but inhabited already. And now, multiply this by the number of galaxies in the universe, also considering that many of them are much bigger than the Milky Way. This gives us billions upon billions of Sun-like stars and Earth-like planets, and some of them are surely more like ours than others. And get this, we might be able to walk upright because of supernova explosions. About 2.5 million years ago, a supernova sent cosmic rays to our planet. They triggered a series of electrical storms in the Earth's atmosphere, which turned into thunderstorms. Those in turn caused wildfires in Northeast Africa, where our earlier ancestors lived. Fires turned the forest area into a savanna, the atmospheric pressure changed, and our ancestors had to stand on two legs to survive. The biggest explosion since the Big Bang was registered in 2019. This happened in the Ophiuchus cluster, which unites thousands of galaxies. According to scientists, the blast was equal to 20 billion, that's 18 zeros, megaton explosions happening once a millisecond for 240 million years. I'll have to trust that. My math is not that good. In 2019, NASA's InSight lander, whose goal was to study the interior of Mars, registered the first Marsquake ever. These quakes were coming fast, about 2 per day. Most of them were tiny. You wouldn't even feel them if they happened on our planet. So far, more than 300 Marsquakes have been detected. Those are the first quakes on any space body other than Earth and the Moon. Another mysterious phenomenon discovered by the mission was bizarre magnetic pulses. They occurred every midnight around the lander. It's still unclear what those pulses were. Maybe after midnight they're going to let it all hang out, or something. Pluto's atmosphere rises much higher above the surface of the dwarf planet than, let's say, Earth's. It also has more than 20 layers, all of them freezing cold and extremely condensed. Remember the asteroid that wiped out the dinosaurs on Earth? Hey, I wasn't around then, but who could forget? There might have been another space show that ended badly for at least 75% of all life on our planet in the past. Roughly 360 million years ago, a supernova explosion occurred about 65 light-years away from us, and the cosmic rays sent by it swept away the ozone layer of our pretty blue ball. Wow, tough neighborhood.
So we're moving to 66 million years ago, in the world where dinosaurs lived. What are we doing here? We're just watching these giant reptiles and waiting for one of the most massive disasters on our planet to strike. Right now, a giant asteroid bigger than Mount Everest is flying at a tremendous speed, exceeding the speed of sound 40 times in the direction of our planet from the depths of space. It passes through our atmosphere, heats up, and hits the coastal part of the island of Yucatan, which separates the Gulf of Mexico from the Caribbean Sea. The enormous release of energy destroys all living things in the area, on land and in the ocean. The air over the island is filled with smoke and ash. Yucatan Island has taken the brunt of the blow. The blast wave instantly turns the green territory into a giant, lifeless crater. The asteroid fell at the wrong time. By the moment of the catastrophe, Earth had already been undergoing devastating changes. Continents were separating from one another, and some volcanoes were waking up, pouring lava onto the ground. Dinosaurs had been almost on the edge of extinction, but the asteroid shaped their fate. Now, Yucatan looks like a giant funnel of melting rock. There are no more dinosaurs here. But what about those animals that were far from the crash site? The noise from the explosion was so loud that pterodactyls hanging out far from the crater flew up into the sky in fear. A Tyrannosaurus got distracted from its hunting and ran away as far as possible, along with Triceratops. But somewhere, even further, in mainland Mexico, ancient lizards continued to chew grass and run around fields. They did notice a bright flash, but didn't mind it. They didn't even hear the sound of the explosion, because the sound wave dissipated in the air. No blast wave, no earthquake, and no meteor shower. Dinosaurs continue with their lives. Unfortunately, not for long. Most dinosaurs would have survived if the meteorite had fallen in a field, ocean, or any other place. Perhaps today, we would see them in nature reserves, but the meteorite fell in the most unfavorable place. According to studies, the giant rock had a 1 in 10 chance to destroy dinosaurs, and it took this chance. It wasn't a soft landing. The stone didn't slip on the ground, but hit the rocky terrain like a giant hammer. The catastrophe wasn't limited to a blast wave and a crater. The asteroid fell into large stalks of flammable materials. Simply put, the space rock got into a giant vat of combustible substances. This provoked a drop of millions of tons of soot and ash into the air. The fire quickly spread throughout the island, emitting black smoke into the sky. Dinosaurs living hundreds of miles away from the site are getting nervous. Feelings of anxiety are growing. Their inner instinct of self-preservation signals that disaster is coming. The sky becomes gray and darkens. Black clouds cover the sun and reflect the light. However, these are not just regular clouds, but volcanic ash. The asteroid fell at the most destructive angle. It also hit the coastal part, so the destruction reached the seabed filled with sulfuric acid. And now it's all coming out. Toxic fumes get mixed with incandescent ash, soot, and metals the meteorite contained. A fiery hot cloud emits acidic smoke that is very harmful to health. And this cloud, driven by the winds, grows and stretches all over the continent. It's getting cold on the ground. Plants, grass, and trees are quickly withering. The green valley, saturated with life, becomes gray and lifeless, which leads to an imbalance in nature. Most dinosaurs can't get fresh grass and leaves. This problem also affects predatory reptiles, since the number of herbivorous lizards significantly decreases. Animals start to freeze and starve. They move away to search for some food and find a warm place, but it's too late, because a poisonous firestorm is approaching them quickly. Dinosaurs try to hide in burrows and caves. Some lizards are looking at the sky, which is getting darker each second. A tiny sparkle slowly falls from a black, fiery cloud. This is a particle of hot ash. It drops to the ground, touches the dry leaves, and sets them on fire. Millions of such particles fall to the ground. The forest flares up like a match. The smoke from the burning trees rises and becomes part of the expanding ash cloud. The more the fire spreads, the larger the ash cloud becomes. Sulfuric acid vapors mix with molten metal particles and fall to the ground as poisonous droplets. Acid rain corrodes vegetation and poisons the soil. Flying lizards rise into the sky and enter the center of the firestorm. Dinosaurs on the ground are running from the forest towards the water, but it's impossible to escape from the apocalypse. The scale of the disaster is increasing exponentially. While acid rain and firestorms destroy one part of the continent, the coastal side faces another problem. The fall of the meteorite caused a giant tsunami. It hits the shore and floods large areas of land. After the massive explosion, the first wave forms. It could quickly destroy modern-day New York. A series of smaller waves, the size of a 5-story building, sweep across the Atlantic Ocean and the North Pacific Ocean. Giant tsunamis are not so scary for deep-sea dinosaurs, but the poisonous cloud poses a danger to them. Particles of sulfur and ash cover the sky above the water surface and bring down poisonous rain. Seaweed and phytoplankton don't survive it. Thus, millions of fish face the threat of famine. This causes huge problems for the whole food chain in the ocean. Giant sea lizards can't survive either. The meteorite created a domino effect that put the entire continent under threat of extinction. A few weeks have passed. The ashes have settled and cooled down. The fires are over, and the air has become cleaner. The sun is finally peeking through the clouds. But the planet looks different now. Giant lizards don't exist on the planet anymore. Green forests have turned into gray fields. Fortunately, not for long. The seeds of plants and trees have survived the apocalypse and are now blooming with renewed vigor. Nature is filled with colors again. Little creatures similar to rats have been hiding in the ground and have also survived. And now they finally get out to continue spreading life. It wasn't firestorms, tsunamis, fires, and lack of sunlight that destroyed the dinosaurs. The primary damage to the world at that moment was the disruption of the food chain. All big herbivorous dinosaurs and giant toothy monsters lost their food sources. Small animals and some flying dinosaurs survived to further evolve into modern birds and mammals. Large animals, the size of a rhinoceros, appeared 15 million years after the disaster. Tens of millions of years passed since that moment, and then humanity appeared. Thanks to modern technology, we've discovered the reasons for the destruction of dinosaurs. We don't know every detail, but we have a common picture of those events. And the scariest thing is that if the same asteroid fell again into some explosive terrain, we wouldn't be able to do anything about it, and our remarkable technologies wouldn't help much. Yes, we might disperse ash clouds and extinguish some fires, but it would be insignificant. Floods, fires, and acid rain would make life in big cities unbearable. The only thing that would help us survive could be underground bunkers and other reliable shelters. But how to survive the famine that would come after the destruction of vegetation and crops? We are developing and improving technologies that can protect us from asteroids, like lasers or space rockets with explosives. But even if we destroy one big rock, it might tear into 1,000,000 pieces. Some will burn up in the atmosphere, and some will fall on the planet in the form of a meteor shower. Anyway, we'll face huge natural disasters. Therefore, all we can do now is hope that no rock from space will come to us.
Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why. Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by 1.5 minutes or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be endangered, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry?
Imagine a planet where every breath you take electrifies your body like a shot of espresso. The sky above you is an intense shade of blue, while colossal trees stretch towards the heavens, their vibrant green leaves growing at an astonishing rate. Daily exercise becomes a thrill like no other. With the abundance of oxygen, you become a supercharged version of yourself. Running feels effortless as you dart across the landscape, lifting weights that would normally seem impossible. It's as if the world itself is infused with a surge of energy. Everything is moving faster. The wildlife surrounding you is equally affected by this oxygen overload. Animals roam the land in majestic proportions. Their massive frames are propelled by speed and agility. Picture yourself in a pulse-pounding chase with an oxygen-charged cheetah, racing against a predator that could put a Ferrari to shame. Now you may wonder how such a wild scenario could ever be possible. Well, let's see. Oxygen is the powerful fuel that keeps life going. It makes up about 21% of the air we breathe, and every breath we take delivers these tiny molecules to our cells, giving them the energy they need to thrive. Without oxygen, our cells would struggle, and our bodies would fall apart. But that's not all. Oxygen is a superstar that works for all kinds of living things, from tiny bacteria to giant elephants. It's even important underwater, where it enriches the oceans. Amazing creatures like plankton and algae produce lots of oxygen, creating a thriving underwater world. But to fully understand the impact of high oxygen levels on the planet, prepare for a journey back in time. Recently, scientists have made an astonishing discovery. They tested rocks from two different places that were really far apart. And can you believe it? These rocks held tiny pockets of gas that showed how oxygen levels shot up by almost a third in a very short time. It was like a breath of fresh air. So they studied these rocks and found that oxygen levels back then were much higher. Imagine lush landscapes, towering forests, and gigantic swamps that stretched as far as you could see. During the Carboniferous period, oxygen ruled the atmosphere at an impressive 20%, just like today. But over the next 50 million years, its levels shot up to a crazy 35%. Can you imagine what that did? As oxygen surged, something incredible happened. Huge forests grew all over the land, creating a breathtaking green world. And massive swamps took over low-lying areas, making the landscape look surreal and otherworldly. At the same time, carbon dioxide levels dropped. Normally, when things break down, microbes release carbon dioxide into the air. This gas acts like a warm blanket, trapping the sun's heat and raising temperatures. But in the mysterious swamps where these giant plants were buried, the microbes couldn't do their job. The result? The planet got really cold. Who would have thought that a breath of fresh air could have such power? The scientists are still trying to figure out why this happened. But one thing is certain, it wasn't just happening in one place. It was a worldwide phenomenon. It was like the planet was playing a funny game with the climate. But let's go even earlier. We see the first North American dinosaurs making their grand entrance. High oxygen levels are what gave a big boost to the rise of mighty dinosaurs in North America and beyond. Picture tropics filled with the magnificent giant creatures. Obviously, dinosaurs didn't just appear out of nowhere. They took advantage of a changing environment that was perfect for their evolution. Oxygen levels played a huge part in this dinosaur party. As oxygen levels rose, so did the size of these incredible creatures. They started small with predators like Chindosaurus, and soon after, huge dinosaurs like sauropods took over the land. Then, 65 million years ago, dinosaurs disappeared and mammals took over. And here's the interesting part. Mammals never grew as big as dinosaurs. So what's the explanation for this? Mammals, and humans are mammals too, by the way, are special because we can regulate our body temperature. But that comes at a cost. We need a lot of energy to stay warm compared to reptiles and dinosaurs. Dinosaurs didn't bother with temperature control, so they could focus on growing big. The biggest dinosaurs were 10 times larger than the largest mammals. It's like a game of anything you can do, I can do 10 times bigger. Dinosaurs might have had similar limitations with their sizes, but those were much less strict. Before the dinosaurs' extinction, mammals were very small. Many mammal species disappeared along with the dinosaurs. But survivors took advantage of the open ecosystem and rapidly diversified into various body sizes. However, after 42 million years of growth, mammals reached a size plateau. This happened on all continents, most likely because of the temperature and land area. Colder environments allowed mammals to grow larger. Balancing body size and heat became challenging. Land area also played a role in sustaining big populations. But making animals bigger isn't the only thing high oxygen can do. This humble gas is a true jack of all trades. It also acts as our loyal bodyguard, protecting us from harmful UV rays and other dangers from space. Without oxygen, we would be defenseless against space threats. Oxygen also has a fascinating role in shaping the weather. It teams up with its other atmospheric buddies to make the sky go wild with tornadoes, hurricanes, and thunderstorms. They mix and mingle in the air, creating just the right conditions for these exciting weather adventures to happen. And these adventures can be dangerous, but they serve an important purpose. They help distribute nutrients and organic matter, carrying soil, leaves, and debris to new places. So what if we decided to mess with nature and crank up the oxygen levels to crazy heights, 30%, 40%, or even 50%? Well, too much of a good thing can become dangerous. Oxygen toxicity is when too much of this gas causes big problems. It's like eating loads of candy. It's fun at first, but soon enough you'll regret it. Surprisingly, an overdose of oxygen can leave you struggling for breath, like a tired dancer in desperate need of a break. At first you might feel a burst of energy, but it doesn't last. Dizziness sets in, as if you've been spinning on the dance floor for hours without stopping. In extreme cases, too much oxygen can even harm your body, making you feel like you've crashed into a huge truck. So while oxygen is always with us, giving us life, it's important to appreciate its delicate balance. Don't put on your special breathing gear. Also, we wouldn't be the only creatures to suffer from this oxygen extravaganza. Mammals, for example, will struggle to adapt to these extreme levels. The balance of power among species will change drastically, and winners and losers will fight for survival in a world that's spinning out of control. And we'll need stronger shelters to deal with these gigantic animals. We'll have to stay nimble and avoid danger. Amidst all the chaos, there will be astonishing adaptations. Birds will fly higher than ever before, reaching heights that would amaze even the clouds. Also, get ready for more natural disasters and delicate ecosystems hanging in the balance. Fires will start quickly and rage fiercely, making wildfires a constant threat. Even a small spark from a campfire could cause disaster. We'll need to rethink our cooking and heating methods to stay safe in this oxygen-filled world. But let's not forget the other side of the oxygen story. If we had a planet with low oxygen, only around 15%, we would face a completely different struggle. Every breath would be difficult, leaving us tired and struggling for air. Physical activity would become extremely hard, and our memory and focus would suffer. So let's be grateful for the oxygen levels we have now. They're the perfect balance for us to thrive. In this exhilarating journey through an oxygen-rich world, we've experienced breathtaking wonders and discovered the delicate balance of our planet. Let's cherish the magic in every breath, respect the interplay of oxygen and life, and embrace the thrill of this remarkable ride called life.
The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change, but if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is red shifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster, because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with light beams and mirrors. But it's not like all we have to do is point a light beam at a mirror and measure its original path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, if it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source, or vice versa, or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on but aren't so bright. You turn on the lights in your room but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking. You're flying through space, dodging stars and black holes. Your speed is so great that you can get from one galaxy to another in just a few minutes. Sound far-fetched? Well, all this can become a reality because NASA has already tested the technology that might allow us to travel faster than the speed of light. Let's look at the space fleet people have now. To fly into space, we use conventional rockets carrying tons of fuel and oxygen. These two substances get mixed and ignited. Fire bursts out of the rockets. The exhaust gases move downward, and the rockets move upward, as if pushing off of them. That's how jet propulsion works. This way, we can make the rocket move at almost 5 miles per second. At that speed, you could cross the United States from coast to coast in a mere 8.5 minutes. But if we talk about space, that's very slow. A trip to a neighboring planet, like Mars, takes about 7 months. And a trip to the edge of the solar system would take about 35 years. That's how long it took the Voyager space probe, launched in 1977, to get there. But we want to travel between stars and galaxies, and the nearest star, Proxima Centauri, is 4.2 light-years away from our home. That would take about 73,000 years to get there. That's longer than intelligent human civilization has even existed. And if you wanted to travel across the whole Milky Way galaxy, which is 100,000 light-years wide, it would take you about 1.7 trillion years. By comparison, the entire universe is 14 billion years old. People just travel too slowly. But even at the speed of light, it would still take 4.2 years to travel to the nearest star, and you'd spend 2.5 million years to get to the nearby Andromeda galaxy. But we can't accelerate like this. That's because the laws of physics say that an object with mass can't travel at the speed of light. A photon of light has an infinitely small weight, but if you want to accelerate even a tiny grain of sand to that speed, you'd need an infinite amount of energy, maybe even more than the entire universe has. But scientists might have found a way around the laws of physics. To create thrust, you need to push off of something. Ships need water. Planes push off of the air. Rockets use the fuel they burn. But this thing, the M drive, works in a different way. A powerful magnetron, like the one in your microwave, sends waves into this cone. It's a resonator. It makes the waves inside bounce off of one of the walls and hit the others. As a result, we have a weak force at the narrow end of the cone and a strong force at the wide end. And if we analyze this powerful force, we'll see that it is directed toward the wide end of the cone. So, the thrust will be in the opposite direction. Now let's make this model much, much larger and put the M drive on a spaceship. The narrow end of the cone faces up. The wide end is turned downward. The magnetron starts to work. The resonator creates thrust and the rocket takes off. It makes no noise and doesn't emit any harmful gases at all. This mechanism can accelerate the rocket much faster than we do with tons of fuel. In theory, we could even reach the speed of light. Sounds great, but in reality, it isn't. Although the inventor of this device tried to prove the M drive works, no independent experiment around the world has shown positive results. NASA sponsored the construction of such a machine in a laboratory, but it didn't create any thrust during the research. Another option that would allow us to travel much faster than the speed of light is the Alcubierre bubble. A Mexican scientist has figured out a way to use the general theory of relativity without breaking the laws of physics. Let's say we have a spaceship on a space-time blanket, and it needs to make a trip to the other end of the blanket. Instead of just moving from point A to point B hundreds of thousands of light years away, the ship starts pulling the blanket toward itself. As the spacecraft folds the blanket, point B moves toward it. Now the ship needs to travel a much shorter distance to point B. It makes a quick trip and then straightens the time-space blanket back to normal. Voila! So such a spaceship doesn't need powerful engines that will burn tons of fuel and oxygen. It would move in a kind of bubble. But the hardest part is creating such a bubble. To do this, we would need an amount of energy roughly equal to the mass energy of all of Jupiter. That's more than we can produce on Earth. And still, scientists are planning to test this technology on a small space probe the size of Voyager. But this experiment might last for decades, or even centuries. Now scientists are trying to reach at least 20% of the speed of light using a laser. And they're planning to get to Proxima Centauri in about 30 years. It's likely to happen like this. A mothership will launch from Earth. It'll carry thousands of fingernail-sized space probes. After reaching orbit, the mothership will launch the probes into space. Each probe will then deploy a sail, a thin, reflective piece of material the size of a parking lot. Then people will focus a powerful laser beam from Earth directly onto the probe's sails. This will give them an acceleration 1,000 times as strong as the acceleration of free fall on Earth. One by one, the probes will launch and head for their destination. We won't even have to maintain that laser beam all the time. If you turn off the engines of a regular ship on the water, it'll start to lose speed due to friction with the water. But space is an almost perfect vacuum. There's literally nothing there. So there's no friction. All we have to do is accelerate the probes to the needed speed. At 20% of the speed of light, these probes could reach the Sun in just 40 minutes. But instead, they will head for the star Proxima Centauri. After about 30 years of travel, 4 more years will pass before we get a signal from the probes. There are several exoplanets in this system, and some scientists hope to find at least traces of life there. But this sail technology can be used in space even without a powerful laser. We can use the sun. If we create a sail the size of a soccer field and unfold it in space, it'll start catching the sun's rays. And since the surface of the sail is reflective, the rays will bounce off the sail. This will create thrust and propel the spacecraft. One disadvantage of this technology is that we can only use it inside the solar system. In cold interstellar space, the sail won't be able to catch the sun's rays or solar wind. Another candidate for faster-than-light travel is an ion thruster. Like a conventional rocket, a spacecraft with ion thrusters would be propelled by gas ejected outward. Only, in this case, the gas would be ejected not because of fuel combustion, but because of an electric field. We'd need to create a powerful electric field inside the engine. Particles of gas passing through this electric field would get accelerated and ejected outside. This would create thrust. And although the acceleration in such an engine would be many times weaker than in a conventional rocket, the ion engine would be able to reach higher speeds. NASA was planning to build an ion-powered spacecraft to fly to Jupiter. Ion engines consume a lot of energy, so the ship was to be equipped with a nuclear reactor and lots of solar panels. 8 large engines were supposed to accelerate the spacecraft to about 56 miles per second. At this speed, the trip from New York to London would take 1 minute. So far, this technology has been actively tested on different space probes, but it can't provide a solution to how to travel faster than the speed of light. Perhaps people will still be able to travel between galaxies in conventional rockets, but they'll need to use some sort of shortcuts called wormholes. So, back to our space-time blanket. Point A lies at one end, and point B is at the other. Instead of traveling across the entire blanket for millions of years, you can simply fold it. Then point B will be right above point A, and you can quickly get there through a short tunnel between them. Such tunnels are called wormholes. Some scientists believe that wormholes can be inside black holes. But there are two problems here. The nearest black hole is 1,500 light-years away, so a trip there would take eons. The second problem is the hole's gravity. Black holes have the strongest gravitational pull of any object in the universe. Their gravity can crush any spacecraft. That's because the gravitational force increases with every inch you move closer to the black hole's center, and the force affecting the nose of the spaceship will be much stronger than the force that affects the tail. The spaceship will stretch out like spaghetti and get torn apart. But there's a theory claiming that a spacecraft or even a person can survive falling into a black hole, but only if the black hole is supermassive, like the ones that lie in the centers of galaxies. They can be millions and billions of times heavier than the sun. But even though they're heavier, they're also bigger in size. This means gravity probably doesn't increase so fast there. You or your spacecraft might not turn into spaghetti, and might even get to see what's at the heart of the black hole.
So, what would it look like to go around Earth at the speed of light? Well, I'm guessing pretty quickly, but let's get to the details. Traveling around Earth at the speed of light would be an astonishing sight to behold. If we could magically achieve such a feat, here's what it would look like. As you kicked off your speedy journey, everything around you would get blurred. The landscape would transform into a streak of dazzling lights, like a cosmic fireworks show on Fast Forward. The world would appear distorted, with buildings and landmarks merging into streaks of brilliance as you zip past them. The familiar features of cities would become blur colors, blending together in a mesmerizing display. Day and night would blend seamlessly, since Earth's rotation would become an indistinguishable whirlwind. However, keep in mind that at the speed of light, time itself would behave strangely. To you, the journey might feel instantaneous, but when you return, you'll find that much more time has passed for everyone else. It's like taking a lightning-fast trip while the rest of the world ages. Sadly, achieving the speed of light is currently beyond our technological capabilities. Okay, but do you know what the speed of light actually is? In the vast expanse of empty space, the velocity at which light travels is an astonishingly precise figure. This translates to approximately 186,000 miles per second, a universally recognized constant notated as c, or the speed of light. Drawing from the revolutionary principles of physicist Albert Einstein's theory of special relativity, which forms the bedrock of modern physics, we come to a remarkable realization. Nothing in the entire universe can surpass the velocity of light. According to this theory, as an object comes close to the speed of light, its mass spirals toward infinity. Consequently, the speed of light operates as an indisputable cosmic speed limit, casting its influence over the entirety of the universe. Such is the fixity of light's rapidity, yes, I have a thesaurus, that it finds purpose in defining internationally accepted units of measurement, like the meter and mile. The United States National Institute of Standards and Technology reveals that the speed of light even contributes to the definition of the kilogram and the temperature unit known as the Kelvin. Now, let's talk about the speed of dark. Darkness, the elusive counterpart of light, seemingly travels at the speed of light itself. In reality, darkness doesn't exist as a distinct physical entity, but is rather the absence of light. Whenever you block out a substantial portion of light, like when you cup your hands together, darkness fills the void. When discussing speeds, we can think of darkness as what emerges once the light ceases to illuminate, and it appears to move at the speed of light. Still with me? Yeah, my brain is starting to ooze out my ears too. Anyway, let's take a journey to distant space, far away from any light sources, such as the radiant sun. Imagine having a light bulb attached to the nose of your spaceship, emitting its luminosity in all directions through space at the speed of light. Now, if you momentarily turn off the light bulb and then turn it back on, a fascinating phenomenon occurs. Light continues to travel outward in all directions from before you dim the bulb, and subsequent light beams follow after you restore its glow. However, amidst these expanding spheres of light, an intriguing region emerges. It's the space in between there was no light because none was generated during the brief period when the bulb was off. So, in this cosmic spectacle, darkness appears to join the journey alongside light, seemingly chasing it at the speed of light. It reminds us that even in the absence of light, there is an enchanting interplay between shadows and illumination, each playing its unique role in the vast tapestry of the universe. 20 miles south of Olympia, Washington, there are strange 8 feet tall and 30 feet wide grass mounds. They cover an area of nearly 1 square mile. These small hills are known as the Mima Mounds, and nobody knows what created them. They've been haunting the dreams of geologists for nearly 200 years. Scientists have been arguing about what exactly caused these mounds to pop up all over the place. There are such theories as earthquakes, glaciers, gas vents, clay swelling, and even termites. In 1942, geologists supposed that pocket gophers could create the mounds. In 1987, the theory was tested. Small bits of metal were pushed into the mounds and monitored with the help of a metal detector. As gophers dug their burrows, the pieces of metal were pushed uphill. A computer program analyzed those results. It turned out that many generations of gophers could indeed form the mounds. It would take them over hundreds of years. But why would they push the soil up when it takes way less energy to move it behind them? That's unclear. So far, gophers' involvement is still just a theory. Scientists used to consider the Amazon rainforest a large ecosystem that's been filled with trees for millions of years. Yet when the 16-foot wide Amazon rings were discovered, it changed all the theories. These rings proved that the area looked very different before forests started growing here. It looked like a modern savanna. Scientists took soil samples near the lakes, and the results showed that this soil didn't come from a rainforest. It was from dry lands. It may mean that people who used to live here probably had a completely different environment from what scientists thought. Geologists are still studying the rings, and they're trying to figure out what purpose they serve. Known as the Eye of the Sahara, the reshape structure is a 30-mile-wide ring-shaped object in the middle of the desert. Reshape was initially thought to be a meteorite impact site, but now scientists believe that it was created by the erosion of a hill or mountain. It eroded away over time, but left layers of rock rings that were once a mountain. The eye is so prominent that the astronauts on board the International Space Station can see it from up there. Antarctica is the coldest, driest, windiest place on Earth. But the strangest thing about it might be located deep under the ice. Until about 60 years ago, Antarctica was considered flatland. That all changed in 1958 when the Gamburtsev mountain range was discovered. It was hiding under 2 miles of ice. Its peaks were more than 10,000 feet tall, and the whole range stretched for 750 miles. That's 1/3 of the height of Mount Everest and about half the length of the Himalayas. No one has ever laid eyes on the Gamburtsev Mountains. The ice hides deep valleys and steep inclines. They could show what Earth looked like millions of years ago. Lake Vostok in East Antarctica was discovered in 2012 during drilling. Scientists found a freshwater lake, untouched and unfrozen, under more than 2 miles of ice. Researchers believe that undiscovered microorganisms and unique geochemical processes might exist in the lake. After all, it hasn't seen sunlight or been exposed to Earth's atmosphere for over 15 million years. But drilling into the lake is likely to ruin the ecosystem below and contaminate one of the last untouched places on the planet. There's a 350-foot anomaly in the Indian Ocean, known as the Indian Ocean Geoid Low, IOGL. It produces the largest distorting natural gravitational force in the world. Heavy mineral deposits, many deep-sea trenches, and magma reservoirs disturb the magnetic field in this area. Earth's gravity changes in different places around the planet. It allows researchers to look for patterns and figure out what's happening beneath the surface. Higher gravity fields usually means denser materials below, and vice versa. Some scientists believe that the anomaly might be a dent in the planet's mantle, that it's working its way up to the crust. The Cave of Crystals in the Mexican state of Chihuahua. These caverns are filled with amazing gypsum crystals that crisscross the entire subterranean area. The caves were discovered in 2000, when workers were draining water from a zinc mine. That's when they stumbled upon these sparkling structures. The crystals were so pure and large, around 33 feet in length, and had such sharp edges that geologists couldn't date them using conventional methods. Luckily, researchers discovered 50,000-year-old bacteria samples within one of the complex constructions. It was extremely hard to work in the caves. There, the temperatures reached 136 degrees Fahrenheit, and the humidity was extremely high. Scientists needed special cooling equipment to get down to the cave, even though they only made short trips. Unfortunately, the company that owned the mine re-flooded the cave system, preventing any further study. Around 450 miles away from Bangkok, in northeast Thailand, there's a 75-million-year-old rock formation. These rocks look like 3 whales swimming together. The beautiful design created by nature became known as 3 Whales Rock. Millions of years ago, this area was just a desert, but the land was changing. Gradually, sandstone got pulled apart by the movements of tectonic plates and erosion. That's how these spectacular formations were created. If you decide to explore the system of trails around 3 Whales Rock, you'll find waterfalls and abundance of fauna and flora there. Locals call the Potomsky crater in Siberia Fire Eagle's Nest. It's a gigantic 500-foot wide and 100-foot tall limestone mound. Nothing grows near or on top of it, and animals do their best to avoid this place. First discovered by geologists in 1949, the crater is believed to be around 500 years old. The most likely theory of its origin is a burst of steam. This could happen during a period of rapid gas expansion in the region. Scientists think that Fire Eagle's Nest might be a very rare gas volcano. Gigantic gas stockpiles might have been trapped deep underground. It could happen because of limestone forming around these storages and creating immense pressure. A sudden release of the stored gas could have formed this mammoth-sized hole in the surrounding forest. Lake Hillier in Western Australia is only 2,000 feet in length, but its color has been baffling geologists for a long time. Unlike most pink lakes in the world, Lake Hillier has a pink color all year round. Its hue isn't affected by sunlight or temperature. If you look at it from above, the lake's bright color will be in stark contrast with the surrounding blue of the Great Australian Blight. The real reason for the Hillier's unique color is still not fully understood. Many presume it has something to do with microalgae in the lake, or it might be a reaction between salt and sodium bicarbonate found in the water. The Chocolate Hills in the Bohol province of the Philippines are covered in lush green vegetation for the largest part of the year. But these 1,200-plus mounds turn a chocolate brown during the dry season. That's what gave them their name. Strangely, no trees or shrubs grow on them. Another mystery is how the mounds managed to develop so symmetrically. There are myths that involve giants throwing boulders at one another for days on end during a fight. Scientists believe that the 150-foot tall mounds were created by eroding limestone that was stacked on clay. But to this day, the mystery of their formation remains unsolved. The Great Unconformity represents about 1 billion years of missing rock records. It appears in all kinds of rock formations all over the world. Scientists have been trying to find the answers to how and when this enormous amount of material could disappear. One of the most plausible theories involves glaciers. It could happen during the time known as Snowball Earth. That's when the planet was completely covered by ice. Then glaciers tore away hundreds of thousands of tons of rock and dirt. This left a gigantic gap up to a mile thick between the neighboring rock layers. Some geologists think that the record went missing when the supercontinent Rodinia formed and broke apart. Located on Yamal and Gedon peninsulas, these expansive pit holes were discovered in 2014. They seem to be still changing and evolving. The pits grow wider and people find them more often. Of course, there's no shortage of theories about how they appeared. Suggestions range from meteorite impacts to the activity of other civilizations. But the most common explanation is that methane gas reacted to water particles after the planet's permafrost started to melt. This resulted in bubbles of methane bursting through the ice. The craters could be thousands of years old, but nobody knows for sure. It was 29,002 feet in 1954. 22 years later, it grew by 27 feet. In 1999, the top was 7 feet higher. In 2020, it was 3 feet less than that. What gives? Mount Everest is still the tallest mountain in the world, even though its height is constantly changing. It had been measured for the first time long before anyone even climbed it. In the 19th century, there used to be this thing called a theodolite, the grandfather of mechanisms engineers and land surveyors use today. It measured the angles between two horizontal points. After that, it would go with basic trigonometry to measure where the third point is and how distant it is. That's how mountains are measured. It was complicated because people who measured it had to know where sea level is. Now, there's no sea near the Himalayas, which is why surveyors had to walk all the way from the Bay of Bengal to do the measuring. Others who tried to measure Everest later got similar results, but never the same. Sea level is constantly going up or down because of changes happening on Earth, so it's not easy to be that precise. Mount Everest is part of the Himalayan mountains, and the whole chain is getting taller by around 1/5 of an inch a year. The tectonic collision that created the Himalayas in the first place started 50 million years ago, and it's still going on. That causes growth, but also brings earthquakes that are in charge of reducing its height. So the information from older geography books may not be accurate these days. Mount Everest is the tallest mountain, but only compared to those measured above sea level. There's Mauna Kea volcano in Hawaii, and if you measure from its underwater base, it's 4,000 feet taller than Everest. Antarctica actually has several time zones, 9 of them to be precise. The Great Wall of China. Nope, it can't be seen from space. Sure, sometimes you can identify it when in lower Earth orbit, but at these heights you can see many structures built by civilization. For example, the Great Pyramids of Giza. When on the moon, you can see some green vegetation and a beautiful, mostly white sphere, lots of blue, and patches of yellow. Nope. Oh no, you swallowed a gum accidentally. No worries, your body won't need 7 years to digest it. It's a myth our parents told us to stop us from swallowing gums. Your body can't digest the ingredients found in gums, so it'll simply move it along. You don't swallow 8 spiders a year while sleeping. Spiders, luckily, don't care about humans, and they don't have any prey or something else that might interest them in your bed. They see you as some kind of a big rock. The air coming from your mouth is creating vibrations that will stop them from trying to get into your mouth. A popular story that famous physicist Albert Einstein failed math in school isn't exactly true. He failed in botany, zoology, and language sections at an entrance exam to a school in Zurich. He was always great at math. Boy, I sure wasn't. It never added up for me. Humans and dinosaurs never really coexisted. They missed each other by over 60 million years. Oil won't prevent pasta from sticking. If you like adding oil, feel free to, but it will only make pasta greasier. Stir it to stop it from clumping. You only use 10% of your brain, or not. You never use 100% of your brain all at once, but you use every region almost every day. Your brain needs to work at full capacity all the time because that's something that keeps you alive. Bananas don't grow on trees. They are big herbs that resemble trees. Pineapples grow from the center of a leafy plant that's on the ground. Goldfish may not be the smartest animal ever, but their memory is longer than 3 seconds. It's up to 3 months, which isn't a lot, but enough for it to remember your 3 wishes. Shaving won't thicken your hair. It'll grow the same as it was. You may only think it's darker or coarser because the hair will grow back with a blunt tip. Coffee lovers, don't worry. Caffeine won't dehydrate you. It does have a diuretic effect, but still, the amount of water in your coffee has the opposite effect, so you're good. You won't damage your eyes if you're too close to the TV screen. That blue light coming from it causes strain in your eyes, but it's a temporary condition. Dogs see more than black and white. They can't see the full color spectrum as humans do, but the world is not a couple of shades of gray for them. They have around 20 to 40% of visual acuity humans have, so distant things may be pretty blurry for pups. But they see better in dimmer light and can detect motions or any kind of movements way better than you do, especially when the delivery guy is approaching the front door. Bees aren't only attracted to yellow out of all shades, they also see colors a little bit different than humans. They recognize only lighter ones, such as green or yellow. All darker colors look black to them. That's why they're more likely to go for flowers with light colors and clothes of the same tones. If you're wearing a green t-shirt, you might look like a flower to them. Almost all creatures on Earth have a limited lifespan. One species of jellyfish is immortal. It matures, but at one point it simply reverts back to the juvenile polyp stage. That cycle of phases is endless. There are many types of berries, but a strawberry is not one of them. Scientists define berry as a plant with 3 distinct layers. There's an outer skin, a fleshy middle, and internal seeds. That means watermelon, grapes, and eggplants are technically berries. Polar bears aren't really white. They have black skin, and their fur is clear and hollow. They only look white because light hits their fur and stays trapped inside of that hollow part of a particular hair. That causes something called luminescence. With all that, salt particles stick to their fur and then start scattering light. If you set a chameleon on a yellow surface, it'll turn yellow. If you set it on a red one, it'll turn red. In fact, chameleons don't change their own color to adjust to the color of their surrounding. Their mood, the amount of light, and temperature makes them change color. So, when you see a bright yellow chameleon, it might be angry. Giraffes have the same number of neck vertebrae as you do. An average human neck is only 4 inches long, while giraffes usually have a 6-foot neck. But both have 7 bones in their necks. Pirates don't have eye patches to cover an eye that's missing, but to increase their night vision. They had to be aware of everything going on around them. So, many think it's just a dry desert with nothing but sand over there. But research shows there's definitely water on Mars. Scientists found big saltwater lakes under the ice at the planet's south pole. Bats are not blind. Their eyes are small and they don't see that well during the daytime, especially not so sharp and colorful as humans do. But their vision is adapted to different conditions and is excellent during the nighttime, unlike ours. Black holes aren't invisible. A black hole is a very compact and huge object that has an extremely powerful gravitational pull, so strong even light can't avoid it. The swallowing center is something scientists call the event horizon. It's surrounded by a glowing circle made of rock, debris, and space dust, so it can be seen pretty well. Scientists even got the first pictures of it. Despite what the name says, Iceland is not really covered with ice. The coast is ice-free during the entire winter. There are glaciers, but also lots of geysers and active volcanoes. In 2010, one of them woke up and threw up so much ash into the sky, air transport across Europe had to be stopped for a couple of days. Green peas, lentils, peanuts. Wait, peanuts? Yup, that's right. They don't belong to the group of nuts, but legumes. Moon has a dark side. Not quite. The side that's facing away from the Earth is no darker than any other part of its surface. Sunlight equally falls on all of its sides, so it only seems to be dark from our perspective. This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into 2 huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, Some of them will crash into each other, others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day, and the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now. Oh, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge super lake. 300,000 years from now, the triple star system WR104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new Oceanic Gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, remember we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football.
15,000 years after the construction of the first space colony, planet Kepler 452b, 1,400 light-years from old Earth. Hello, first-year students. We're glad to welcome you to the Intergalactic University. Endless space is now home for us humans, but thousands of years ago, we used to live on just one planet we now call Old Earth. Yes, I understand it's difficult to believe. Today, it's one huge nature reserve. Mammoths and stegosaurs walk on its surface, and pterodactyls fly in its skies. It turned out to be easier to recreate animals that roamed it millions of years ago than to understand how our ancestors lived. The Great Cataclysm made them abandon the planet in a hurry, leaving much of its legacy behind. And now, we're studying it anew. But our excavations leave more questions than answers. Skyscrapers, highways, shopping centers, coffee shops, everything is buried under sand and soil. Rust has eaten away the metal, and time turns concrete into dust. Even the Hoover Dam and the Three Gorges Dam in China have crumbled. The colossal structures turned into heaps of stones. The remaining buildings have become overgrown with plants and turned into a home for millions of living creatures. But there's good news as well. Faces carved into Mount Rushmore are still visible. The mountain is granite, and this rock is one of the hardest on old Earth. For over 15,000 years, the faces of U.S. presidents have deteriorated by only 2 inches. The monument will stand for millions of years. And the latest expedition to the Sahara Desert managed to dig out the Great Pyramid from the sand. Now any tourist can buy a ticket and look at that wonder, which even Earthlings considered very old. Surprisingly, ruins and crumbling walls of medieval castles in Europe have survived. They're built of massive stones and without metal fittings, which expand and destroy the stone when rusting. Our ancestors left behind a huge amount of garbage. Empty bottles, plastic packaging, wrappers. All this helps scientists to recreate the consumption patterns of people of the past. Thanks to this, we know for sure that in the 2000s, almost 8 billion people ate mostly chips, chocolate bars, and pizza. And they rarely drank ordinary water. They loved coffee, though. 60% of Earthlings lived on the internet for 7 hours a day. 2 billion websites worked 24/7. At first, information was stored on hard disks, flash drives, and compact disks. But this kind of storage went obsolete after a couple of years. The cloud took their place. It was an online storage with servers connected to the global network. They recorded the entire life of Earth's civilization and were stored in data centers. In space, the Earth's internet didn't work well. Apparently, huge distances and lack of technical knowledge did their job. Imagine that a Pluto resident wants to know the difference between margarita and calzone pizzas. They click the link and wait for a couple of hours for it to open. If the dough's already in the oven, no good. Each colony organized its own internet by sending satellites to orbit their planets. It took time to connect thousands of colonies into the intergalactic web we now know as Uninet. When the cataclysm struck, people had to escape, leaving their planet to its fate. Electricity went out, no one maintained the servers and data centers, and lots of info about their civilization was lost. We've scanned miles deep into the Earth and found many interesting artifacts. Students, I invite you to look at this amazing thing. The Earthlings called it a camera. People took pictures of their food, morning runs, and new shoes on it. One thing our scientists couldn't comprehend, though, is that ancient people used to communicate with its help too. One of the main mysteries of the past are the dishes of different sizes. Archaeologists find them in almost every home. They bear these names: Buddy, Cosmo, Rex, Princess. We know these were the things from which dogs and cats ate, but we don't know why people pampered these animals so much. For example, archaeologists recently unearthed a beauty salon for poodles in San Francisco. I also love my dragon from the jungles of Galisa 832C, but I don't perm its fur and manicure its claws. And this is my favorite artifact, a book. There's nothing more valuable in the universe. There's only one sample in my antiques collection. It's a cooking recipes anthology. I paid a fortune for it. The ruins of museums are treasures for archaeologists and all the new humanity. These buildings collapsed a long time ago and now look like ordinary hills, overgrown with trees and grass. Museums are like pearls in the ocean. They lie at the bottom and wait to be fished from their shells. And sometimes, archaeologists manage that. Books, paintings, documents, and clothes have mostly turned to dust. But we can enjoy the statues that were carved out of marble by masters of ancient Greece and Rome. On the walls of caves around the world, there are drawings of animals and handprints of the first people. They didn't know how to read, drive a car, or fly a spaceship, but their paintings have survived. It's incredible Over thousands of years, time has eaten up huge dams, cities with skyscrapers and bridges, and the palm of an ancient human still adorns the cold and rough wall of a cave. Space archaeology is becoming more and more popular. Thousands of tons of space debris fly around old Earth. The real sensation is the discovery of the Voyager 1 probe. Earthlings sent it into space at the very beginning of their development. I see your condescending smiles. Today, such a device can be assembled by any first-year student from spare parts in their parents' garage. But, dear students, let's not laugh at our ancestors. They tried their best. Voyager isn't a simple satellite. The device can be compared to a message in a bottle thrown into the sea. And the cosmic sea is millions of times larger than the Pacific Ocean of old Earth. Engineers of the past left a time capsule with a message in the probe. It contains photographs of people and the nature of the planet, as well as scientific information about the Earth. 90 minutes of recorded music are of particular interest. This is a real gift from our ancestors to us, to the people of space. Radio signals that humankind sent into space have also survived. We've tracked them. Radio broadcasts, phone conversations, even music charts continue their journey through space. Millions of years later, they'll weaken and leave behind only an electromagnetic echo. In 2020, there were 1.4 billion cars on old Earth. Unbelievable! But they moved along asphalted roads on rubber tires, not in the air. When humans flew into space, they left their vehicles on the planet. Within just a couple hundred years, the cars went completely bust and turned into piles of metal, plastic, and rubber. One that survived for millennia was the lunar roving vehicle. There's no air, no water, and no earthquakes on the moon. Anything that comes here becomes kind of suspended in time, and that's what happened to the rover. Archaeologists have found a lot of other whole and crashed spacecraft on the moon. These devices are priceless artifacts in the Museum of Primitive Earth Technology. In the Svalbard archipelago in the Arctic Ocean, scientists have unearthed the global seed vault. Earthlings built it in 2008. It became a real sensation. The huge silo contained 4.5 million samples of 500 seeds each. Billions of seeds have helped provide agriculture for the colonies. Now you can eat popcorn and hamburgers with real bread rolls thanks to those. For thousands of years, the seeds were kept without human attention. This isn't a miracle, but an accurate scientific calculation. The vault is built underground at a depth of 390 feet. There are no earthquakes or floods there, and the permafrost provided the optimum temperature for the seeds to survive. Most metals are mined from ore. These ores don't contain pure metals, but only their chemical compounds. To get pure iron, the ore must be smelted first. But there's a problem. Metals from ore oxidize on contact with water or oxygen. Simply put, they rust. This is how metal returns to its natural ore state. That's why nails, metal fences, bridges, and houses rust and collapse. But this doesn't happen with gold, silver, and platinum. Things made from these metals are eternal and will never lose their shape. Of course, if you don't start hitting the rings and pennants with a hammer. During excavations, archaeologists find thousands of jewelry items. Earthlings love to wear them on their bodies. Crowns, luxurious necklaces, wedding rings,